Hi, my name is Bob Grenier, and welcome to this presentation, O-Day, Mining Sweeping. I'm a volunteer with Martin Fleischmann Memorial Project, and it's great to have you here on this 29th of May 2022. Okay, I messed that up, didn't I? So I have to congratulate Artifact for finding the feature on the Lion 1 reactor that I didn't spot when I was doing it live, and it would have been great if I did, but I didn't. However, next time I am on the SEM, I know where it is, and I'm going to make it beautiful. But we're going to see it in slightly better resolution than YouTube gave it to everyone. But before we do that, we are going to discuss the overview of the presentation tonight that I hope to achieve, although there's no guaranteeing I will do that. And that is O-Day Mining Sweeping. And I'm calling this mining sweeping. Mining is a sort of a kind of hark back to the first video I did of the Lion reactor, mining diamonds with Lion. And so we have mining in there and sweeping. It's kind of like a nod to that. Now you might be wondering what that image is on the left-hand side. Well, I have actually included that in a presentation before when I was looking at EVOs across a range of systems. And what you are looking at there is in fact a grab of a part of a tapestry I have on my wall, which I bought nearly 20 years ago to the day. And I call it the Love Tapestry because it contains 24, is it 24? I think 24, ceremonial garments that have been stitched together into a kind of patchwork, a kind of like collage from tribespeople of the Rajasthan area of India near the border with Pakistan. And this I felt was an important tapestry to buy at the time. It was very heavy, it cost $600, but I believe it was worth it because it was the love of, let's say, 24 mothers or grandparents, where they would make these garments that would go round the neck of the newborn child, and then people would come from other areas in the desert to celebrate the new arrival. And why I chose it was because in those cultures, they pass down information from generation to generation in art forms, whether that is song or pictorial art forms. And I was very aware that what was going on at the time was the Indian government had decided, look, this country is almost impossible to manage because we have like something like 134 languages, and these people, they don't subscribe into the tax base. Like I think at the time there was only 2% of the country paying tax. And it's very difficult to control people and get them part of the system if they don't have the same ideals, they don't have the same language, we can't communicate with them, they are self-supporting. You know, how can we control these people? So the main idea was to drive roads into every single part of the entire country. That was all through the deserts, all through the jungles, all through wherever it was, such that the roads would allow other communities to come in and homogenize the society. And I thought, what a terrible thing. With the exception of the Andaman and Nicobar Islands, where there are protected tribes on there, which have essentially had no human contact for all of the modern era. So those are protected. But the rest of India, they wanted to get under control. So I thought, well, if I don't buy this tapestry now, then what is in this tapestry in terms of lost knowledge, it will never, you will have to rediscover all those things, understand what they were, and then create an art form to pass that knowledge forward, and then it just won't happen again. So I thought I'd take this, and so you will have seen in a large number of my presentations I've taken aspects of this tapestry, and I believe this is one of the most significant here. And the reason is we have this torus shape, which has these bands around the outside, and these regular array of spots, and then we have a kind of yin yang in the middle, this kind of black and white duality. But then we also have these tails coming out, which also have a kind of like spiraling elements to them in the fabric that's chosen underneath. And then these regular arrays as well of these bright spots. And then on the outside, you kind of have this weave work of embroidery, which is just, you know, to me it summed up a lot. And anyway, what we're going to try and do today, if I can achieve it, is we're going to explore coherent matter. And we're going to look first at structure of small clusters, what we have seen over the last, well, since first examining Lion in the beginning of 2018. A couple of those, and then we will try and look at the structure of the skin of large hollow spheres and toroids. I'm arguing that we now know that they are hollow spheres. It's not just Anatoly Klimov's work or other Russian authors. We've actually got evidence for that, both on the spheres and the toroids, and that these are, in my view, potentially a whole other level class of exotic vacuum object. And I will discuss potentially what that is. And then we've got entrainment of smaller clusters and how that may affect material. And then the reason, I believe, for strange radiation tracks being easier to detect with polarizing filter. So if you recall, back before I went to visit Dr. Roy Shinamaza, I felt, look, I need a microscope, because I'm not going to have access to a microscope. I don't know how long I will have access to anything that I might get presented. But I want to have the ability to separate out things that respond to light in different ways. And this in part came from what I had already seen in Lena. But, you know, I've done a lot of photography over the years, and if you're looking at a landscape, you know, where you've got water or if you've got the clouds, you often don't see the detail in those things because of diffuse light reflection. And this is something I was very aware of from 3D animation, understanding how diffuse and specular and you know, other types of light forms play. But when you are taking with a polarizing filter, you can see through water, or you can see the formation of clouds where different polarizations of light and bouncing off the surface of the water, or bouncing off dust particles or water particles in the air, it blurs everything out, so you don't see the forms that you might want to see. So I was convinced that I need this. I took a bit of heat for doing this. I was spending my own money at the time, but I did do it, and it absolutely paid dividends. And it's been a question for me. Yes, it worked, and did I get lucky? But then it's been a question for me for some time about how did it work? How did it actually work? And so what was the cause of the strange radiation popping out of various samples? And of course, we've seen it in many samples since, but predominantly with the samples on the Amasa vibrator plates. Okay, so we're going to look at that, and I believe I've got a good explanation for that, and so people can move forward knowing that this is a science and the reason behind it. And then lastly, self-evident proof of the of soliton self-sustained disruption. And I've shown things in the past. I've discussed it with the lion, sword in the stone, and related objects like wood becoming part of metal in Hutchison effect samples. But in this case, I think we have an event that occurred post-reactor cool down, and it's absolutely crystal clear. And even the fact that I was using the wrong type of a visual tool on the SEM at the time, but I know where it is. I can go back, and I'm pretty certain we are going to see it in absolute perfect visual acuity. It's going to be really, really clear. And so there will be zero doubt how disruption of matter occurs at the end of this presentation, I hope. And so that will clear up one of the major mysteries of the Hutchison effect. And Lena, in the way that Ken Shoulder said, you know, if you want to create heat, you're going to destroy your reactor. So there are ways to generate direct electricity, and you know, Solin had one, and Ken Shoulders had one, and we've talked about this 1,000-to-1 ratio, also different authors. But if you are going to create heat, typically you will end up destroying your reactor. And I think at the end of this presentation, if you haven't already seen it in the work that I presented earlier this week, you will have a visceral sense of how that is occurring, and also you will know that you don't want these things in your body because they will similarly do unpleasant things to your body, if you didn't believe Shishkin already. Okay, so can everyone hear me? If that's great, that's good. Again, I want to congratulate Artifact for finding the object. It was a fun little challenge, and I will send him a small piece of a Hutchison sample for his toolbox. Excellent. Okay, everyone can hear me. Great. I'm sorry to hear that Space Case has got a fire on the way. Do not risk your life for the sake of this presentation. It will be on YouTube. You don't have to do that. And it's great to have so many of you in the house. All right. Okay. So, first up, we have a structure of small clusters. And way back at the beginning of 2018, I shared these galaxies on the surface of Lion. And we have a 3-point on the left here, and we have a 2-point. And the way I look at these is when these structures died and the reactor was cooling, at that moment, they happened to be basically practically riding on the surface of the reactor. And as such, they showed themselves in terms of their form. And so I believe that we have one tori with 3 tori arranged around it. And as you are aware, my belief is that the torus is able to pull material in from behind it. And so for that to be the case, these must be orthogonal to the main torus. And so that is where the idea of these, the way these are arranged, came about. And so this is one torus in the center with a larger diameter and 3 torus around the outside. Now you could argue that the torus itself is just the magnetic loop, and that the actual tori are not actually attached to another tori. In this case, you can imagine that there's the magnetic loop here, and then we have one torus here and one torus here, and they are pulling in material from the outside. I did try quickly, in the short time I had this week, to try and find these structures and image them in better quality. I failed to do that, but what I did do is I imaged this object in better quality, but not this particular one, so a similar object. And this is the north pole, in my view, of a magnetic flux loop, and that shot material across this valley over to this side. And this valley here, where you have this sort of the base of the valley here with this silver deposit in the bottom, this is actually the oxide that grew on the copper windings that went around the Lion reactor. And so this curves in here and curves up here, and so this cannon is shooting across the valley. So you would have a north soliton here and a south soliton here. And the implication is that they are kind of, in my view, potentially with the soft pole here and the hard pole this way, the soft pole here and the hard pole this way, and so they are. It's kind of like projecting material out this way and capturing it in here. Anyway, that's my view on this matter. Okay, then we saw a 4-point here, and this is your type of swastika type structure, which I had at the front of the first presentation where I shared this material in Sochi on October the 4th, 2018. And this is a 5-point, and I showed you. We've got the Paisleys here cut through, and they are related, and you'll see those again. We've seen those in the Lion reactor and in the Hutchison samples, which we will look at in a little while. Okay, so over here, maybe. Now, on this, I believe actually we have a group of 5 going round, but actually you've got a separate torus here with 2 torus on it, north and south. So you've got your charge separation going on here, and this is kind of like spinning around here, but it's not spinning. But that's a weird thing to think about. But anyway, so these were the ones we had from way back at the beginning of 2018, and then I have shared this week examples from the Vega copper pipe ball lightning cut. And if you look at the top right here, we're looking at this kind of area on the ball lightning cut. I don't know if you can see where I'm moving my mouse. It's up here. And we have this blue cross here. And this, I believe, may be a 2. So this is, in a way, similar to this structure here, a 2, 1. So it still has a ring, but it's coming in from here and coming in from here. So this is a 2 level. So it's coming in from one side and another. So, but notice we have this vortical object here. So whichever way it's pointing, I think probably the north is here, and it's throwing material around here, and the south is here, and this would be the dome, and this would be the dome of the 2 structures, and this would create the vortex that's going in on this particular structure. Okay, like I say, these things will become clearer over time. This, I believe, is a 3 level, and we are looking here with various mixes. This is the secondary electron detector, and this is a mix of the secondary electron detector and the backscatter detector. But again, you can see the vortex coming in here, and you can see that it, just like it did on the Hutchison samples, it's getting deeper and deeper as it goes into the vortex. And so in this case, you would have a torus here, a torus here, and a torus here, and they are churning the material around here. And seeing triangular holes, and in the case of this one, elliptical holes, these are not sort of things that a straight vortex would create. This is a vortex, but made of vortices. This is a vortex, and interestingly, these are going around. This one's going around right hand, and this one's going around left hand. Okay, so maybe the orientation of the subtori are at a different position. And what you can see between these 2 images here is the importance of using different detectors, which are different ways of getting the visual information from the actual object. And I would recommend that if you think you find something important in any of your work, that you're always looking to view that in more ways to try and get more data on it. Okay, so next up is our square one, our 4-sided structure. And in this case, it's very difficult to argue that you're getting a round structure into a square hole. Okay, this is, in my view, 4 around it. So this would be the kind of swastika type structure, but without the maybe the subtori around it. So we've got 1, 2, 3, 4, and the material is flowing around there. And then we have the 5 here. And so we've got a pentagon shape here, and again you'd start to see a hole in the middle. So from the 4th level, it starts to be less about a vortex, but you can imagine it's there. I mean, maybe the vortex is coming in from here. Here it's less clear. So that's 5. Then we have 2 examples here of a 6. So this is at an angle. So we got our 6 here. 1, 2, 3, 4, 5, 6, and this is a more clear example. 1, 2, 3. Well, okay, it's 6. You can work out from this angle, but anyway, and you start to see when we get to 6, in both cases, you get a round hole in the center, becomes a little bit more regular. It was almost like we've got a 6 up here as well, but it's a little bit buried. Okay. Now, then the number 8 here is starting to look like a circle. Okay. And we're starting to get a fairly big hole in the middle. I don't know whether there's some subclustering going on in here. We got maybe 3 different things that maybe this formed and then something went into the center of it. Don't know. Or maybe the bigger structure then collapsed and bits flew out and it ended up with some of the substructures of this 8 forming whatever's going on here. Okay. So what am I talking about when I'm talking about the vortex that you see, this paisley, this extremely important paisley? I was talking about it here. These are the paisleys. These are the paisleys. This is paisley cut right ways. This is paisley cut left ways. And a paisley is one of the symbols of life and eternity from the first monotheistic religion, the Zoroastrian religion of Iran. And so you know, the fact that we have paisleys here and we have paisleys here and we have paisleys here, I believe this is very important. I think these ancient peoples well understood this technology. And here is a more macro vortex where you've got 6 sides here, and this is on the 1986 Bulburn sample. And it's very similar to the sort of structure that you see in the 2019 paper by Bogdanovich et al., which we've talked about at great length. And looking at that in much greater detail with the Narugu microscope here on the left, you can see these almost like buzzsaw type cuts out of this structure. So I believe that this was rotating around this way, and this will be very, very important when we come to the last structure that we will see today, which Artifact saw on the last video that was shared this week. But you see these literally sort of sweeping cuts, and it's kind of like as this goes round, it's sweeping the material and leaving this shape. So this is at, I think, 40 microns, and this is 4 centimeters across. This is from 1986 on the Bulburn sample. This is from 2007 on our large aluminium sample. But again, this is vortical and cut in, and I've shown in the past that this is completely identical shape. There is no difference between these 2 structures, and so you can see here this is the exact same physical, slightly distorted vortex, slightly distorted hexagon. Okay, that is on this sample. Okay, so let me just see if that's all I want to share from this at the moment. Okay, so does anyone have any questions at this point with regard to the kind of levels of self-organization that go on at this sort of the basic? When I'm saying that, for instance, this here is 2 tori around, which may just be magnetically linked. Okay, so you have one here and one here. Okay, and they create a vortex here, but there's a magnetic flux around here, and they have their own vortex from the electron cluster coming in here. So this is these are 2 tor levels, and this effectively becomes a 3 tor level because it's a torus with a magnetic loop of 2 tors. Okay, this is just a 3 around a magnetic loop. Okay. This would be 4, this would be 5, and then we have our 2, our 3, our 4, our 5, our 6s, and our 8. Don't know where the 7 went, couldn't find a 7, that you only have so much time. So yeah, so the reality is that this particular structure, even though this might just be one single tor, I believe that it is a fractal structure. So even when I'm saying we have 1, 2, you know, 2 around, or we have three around, let's like that, or we have 4 around. Each of these tors are themselves a super to the nth degree tor. They just happen to have organized themselves as a group of 4. So it's not to say that they aren't much higher level in their own right. Okay, so that's that. So anyone questions? You got it so far. Excellent. Is self-organizing an aspect of self-sustaining modality? Yes, I think you need to get to a certain level of self-organization so that the structure is stable enough. And in that respect, I will go through some of the objects that we have seen on the Vega Valley Eastern Plateau at this point, because I think that is very, very important to see the top, kind of the high level of this kind of self-organization. So let's see if I can do it like this. Okay, so this is the fractal basic object. You must have at least 3 to represent it, but if you can imagine, this torus is also what these torus are, and then if you imagine the subtorus of those, that would be what they are. Okay, and then we found a range of these structures with different numbers around. So I've shown you in Lion 2, 3, 4, 5, and in the the last one I showed you, which was on the ball lightning cut on a copper tube from Henk Jeren's Vega experiment, that was 2, 3, 4, 5, 6, and 8. These are obviously much more tori around the principal axis. Okay, we've got these in a range of different qualities. This is the 24 level one, and I believe the outside of this just blew off and broke away. And we've got one here with however many it is around here. 1, 2, 3, 5, 6, 7, 8. That's maybe a 24 tor as well. And then we've got a fragment here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So yeah, so you can see that there. So, but again, these 11 pieces of a larger tor have got their own torus around it, and this is it would look like 6, or you could argue that it's just 3. Okay, and it's interesting. The reason I'm saying that is because you tend to have a white bit here and a white bit here, but a dark point here and a dark point here, and it might be that there's just 3 around. And there's another one in this kind of area, if I can find it. If I have that image, I don't know whether I have that image. So no, I don't have that image in this particular set of images. And they have this, when they get to these kind of levels of tors, they're this D4D ratio. Okay. Okay. Here's some other fragments. And the interesting thing about these fragments is that they have a sphere in the middle. Okay. Now, I've argued that in my original diagram of the vortex, that the magnetic core is here. Okay. And the torus is around the outside. Okay. And it could be that the magnetic core here is actually what is iron, and this is calcium around the outside. So you'd have one of these around the outside, and then in the center it has this magnetic focus, and this builds the iron core. However, you know, you've got this iron core here with this zone around it which is protected, and the diamagnetic material can't infringe upon it. And here we have the iron core of a broken up ball lightning, and around it you have things like silicon and calcium. And were these part of a torus? Don't know. And the jury's still out. But the question is, for instance, where this structure is broken up, was this iron, which we know is iron from testing this, was this particular piece a core of this overall torus, or is the core something separate in its own, the iron core is separate in its own right? Well, we're going to talk about a little bit about that and where my thinking is at the moment, and I would like your opinion on that. In this particular view, we have a structure which is a subtors, okay, of a larger torus, and we've got 1, 2, 3, 4, 5, 6, 7, 8 on this, and I imagine that this was at least a 32 probably structure, and we haven't seen them above 48, but anyway, this is a 32. But when you look at the subtor at the end here, and this is the one that I use to fake my center of the Milky Way black hole by taking this structure, which looks remarkably like the thing that came out of the Event Horizon Telescope, and I just recolorized it to the same color recolorization that they had recolorized their grayscale data from. So when you look at that image of the so-called black hole at the center of the Milky Way, it is a grayscale image that they recolored to allow humans to visualize it better. So I took my grayscale here and did the same, and it looks largely the same thing. But like I was saying with that other one here, where it looks like you've got a bright spot here and a bright spot here, and we missed a dark spot, and probably this is a bright spot over here. So you have a bright, dark, bright, or whatever. On this one, it's a little bit clearer in that if you go here, this is bright, then there's a gap, then there's a bright, and that's a gap. And you can imagine that this is a wave coming around here in the coherent matter, but that this potentially is, it could be just that this is the peak of the wave, and this is the trough of the wave, okay? Or it could be that you have a subtorus here and a subtorus here and a subtorus here. So this is a torus made of a 3 torus, which is similar to what we are describing when we are looking at the other work here, where we have this kind of thing going on, where we have a torus made of 1, 2, 3 tori. Okay, so is that clear now? Okay, so there's lots of questions for me at the moment. I'll have to come to those later. All right. So I haven't got the video links you sent me, WP for Truth, but I'm sure I will. Okay. Right. So what happened this week, I think, is very important for understanding the overall thing that's going on in this process. And so I want to talk about the structure of skin of large hollow spheres and toroids. Okay, and the first thing I want to talk about is the fact that Ken Shoulders said you could actually wrap a object with these exotic vacuum objects, and I've argued in the past that that was what allowed the cannonball of John Hutchison to remove the effect of the action of gravity on the mass that's contained within this skinned cannonball, so that then it was just buffeted around by varying electromagnetic waves and even magnetic fields, because he often had traveling wave tubes in there, obviously EMF, he had electrostatic field, and he also used magnets. So very slight variations would rotate it, and it rotates in multiple axes, if people can recall that video. And so in this Hutchison effect fracture, we have the skinning of the surface, and we know it's the skinning because when you cut this inside, you don't see this going through the structure. It's a kind of a wave structure on the surface. And then at the same scale, using the same microscope, but on a non-Hutchison affected material, we have this jewel, which we know is a substructure of the field structure that comes out of a large one of these structures, to coin a word. And on the edge, this edge here, we have the same kind of yin-yang, almost scales, you might like to call it. But this is skinning the surface. And like this goes around this edge and around this edge, we also have this going around this edge. Okay, so this is skinning the structure. And back in Sochi, I said that essentially this led me to believe that the flower of life here was probably, in the fact that I'd actually witnessed this when I was 18 and I went to Beijing, that's some 32 years ago. I actually had my hand on this ball, which is one of the food dragons, the food dogs that are based on ancient Indian temple lions. I always thought it was funny because the Lion reactor and so on. But anyway, I said that this, I believed, was the structure of natural ball lightning, and it was very similar to the tufts that had been seen on the sapphire sphere in the center of the sapphire reactor, and that Henk and Uren and David Bitelier had replicated in their Vega experiments. But of course, tufts are not a new thing. They used to, they're called balls of fire in much earlier work, and they've been known for a very long time. Anyway, so I believe that you had these areas where energy was focused and matter was focused, and then you had something that was binding them together, and that the overall structure was like this, and that this was ball lightning. Now, finding the iron cores in various experiments, starting with the ball lightning reactor of George Eagley, the Nova reactors, the biggest ones that were created were actually created by Alan Goldwater in his Magic Sound lab, following a request by myself, predicting that they would be occurring, due to David Boutilier's finding that the tips of these Yin Yang structures that were broken off happened to be magnetic. And then I saw in my own capture of magnetic structures that there seemed to be these spheres caught in the top of one of my structures. So I said, Alan, I think this is going to be making these iron-rich crenellated spheres. And there's a couple of things that I want you to pay your attention to. Is that we have a ring structure here, okay? And we have this triangular structure here, and we have these meeting points. Now, this will become clear as to why I'm talking about this. So we have another ring here, we have another ring here, we have another ring here, and I've shown you 2, 3, 4, 5, 6, and 8 level structures, and then I've shown you structures on the Vega Valley Eastern Plateau that had something like 12 all the way through to 48 numbers of subcomponents around a ring. And you can imagine that if these were to aggregate together, that they would have to reorganize themselves. So you've almost got a spot here with a ring around it. Is this a ring like the kind of semi-triangular structure we saw? Is this a pentagonal structure? Is this kind of like wanting to be a hexagonal structure with 1, 2, 3? I don't know. But you certainly see these triangular sections here. And from looking at it, you can see that you have carbon and oxygen, and silicon and magnesium and iron here. And if you take carbon and oxygen and fuse those, you get silicon. If you get carbon and carbon, you get magnesium. And you have paths to iron as well. If you take 2 aluminiums, you get to iron, and so forth. So there's different ways to get there. And so this is on the outside. Of course, it's not necessarily going to be so clean, but this one is very, very large. This is 40-something microns across, and this is the biggest one that we have seen synthesized in our work. But again, you can see these triangular sections here. This triangular section here, and this triangular section here, this triangular section here, and so on. And you can imagine that this is kind of how the matter has to be organized, and that you've got these curved sections here, but overall they're forming into a kind of triangular section here, triangular section here, okay? And Alan Goldwater also found in his reactor that he had this triangular piece. Now, it is large. I mean, this is large, but if you imagine this 40-something micron structure tearing and opening out, you could imagine you could easily get something that was this big. And on the inside, you have this very, very smooth area here, and you have these crenellations that are on the back side. And when you look at this on the inside, it is literally just carbon, oxygen, magnesium, and silicon and iron. Literally, that's that. And almost all of it is iron of the heavier elements. And obviously, as I said before, carbon oxygen make silicon, carbon and carbon make magnesium, and so forth, and with the iron. So the inside skin doesn't have the sodium that is on the outside skin, and so forth. Okay, so that's that. Now, what happened this week is we found a toroidal structure that had collided with this copper pipe. And I'm going to go and look at that because this really opened up a couple of really important aspects. So, so what I'm arguing, and I will show in a little while, is that these structures are either the magnetic core of the main soliton, or because solitons are entrained, and you'll see how they're entrained later, that they get focused into that core and compressed into that core, and therefore they are similar structures of the overall tori, and they're built by the tori, but they organize themselves in a slightly different way. And I think we have all the evidence necessary to make a judgment this week as to how that is occurring. Okay. All right. So I'm going to now switch to some of the SEM work that was presented, but I have the actual images, let's put it like that, which are at a very high level of fidelity. So we can zoom into them and stuff. So let me just go and get those for you. Everything clear so far? Okay. Fitting into the minimum volume. Now, that's what it has to do. The sphere is the minimum surface area for the maximum volume, to be precise, and it has the minimum surface curvature, like the torus does also, and a single surface. Okay, so so let's see what we have here. Okay, so I'm going to actually look at the ball lightning cut first. Just to show you this one, this is the, I'm not going to look at the ball lightning cut first, I'm just going to show you this. This paisley, this vortex structure. I had a whole thing, if you go and look at the presentation spirals and triangles, I talked about that in detail, okay? So there's a whole bunch of these different ones. That's the six level one here. This is the 3 level one. What have we got here? There's just a whole bunch. There's the 8 level one here with something going on interesting in the churny mix in the middle. Okay. Now, the key area was this structure here, and it is on the upper side of the ball lightning cut. So this is, to just clarify, I'm not arguing that the iron necessarily is synthesized in this reactor, because essentially this is a big block of iron above rather here, and there was another block of iron below. There was some zinc in play in this reactor. But we looked at this edge on the top of the surface, so around this area here, it's always more interesting to look just a little outside where the main action occurs. And so we found the most interesting features on the Amasa gas affected 10 yen coin, just outside of the main ball lightning structure. And that is the same here, although on the edge of this, around about here, we have found something, I believe, which is completely profound. But also what's on this area here is this structure here. And this is in my view, a toroid cut that was, it's a large structure, okay? And it came in probably from this direction, and you'll see why. And it hit, and it kind of slapped itself down on the surface and bounced off, okay? And what you have around here is actually things like sodium and copper and zinc or whatever over here. But everywhere you see these crenellations, these are high in iron. And in the gaps between them, you have silicon and aluminium. Okay, so these same elements that you are seeing on the spheres, you are seeing in this overall crenellated structure. But all around here, it's kind of, you do have these linear crystals and sideways crystals, these sort of orthogonal crystals, but there's a bit of a mishmash around here. But on this area here, you have them all coming out in a line, which is not true essentially anywhere else in to the same degree. They're all coming out in a line. Okay. Now, when we go in much closer in this area, we find that they are there's something much more interesting going on. So if you actually go to this image, which is showing a good mix between SED and the BSD, we can see that where these lines come in on this edge is that just like on the ball, we have a very, very clear boundary that is homogeneous and goes round, and then outside of this we have the lines coming out. But the interesting thing about these lines is that they are twisted. They are twisted, and you can almost see to a degree that you have above and below, and this is in front here and this is behind. This is in front, this is behind, in front, behind, kind of in front, behind, and so on. So it's almost forward, back, forward, back. See, this is in front, there's a bit, looks a bit behind here, and so on. But it's these vortical nature here. Maybe you can see it more on this one, don't know, we can have a look. It's maybe not so clear, but you can see the vortical nature here. Okay, now I'm going to try and get the elemental maps up here, because this tells a very, very, very important story, which is not necessarily clear from that. Maybe it might be best to just show the video. That might be the best way to do it, actually. So we'll go through, I think, the video here. Okay. So you can go and have a look at this video in your own time. But I think the important thing here is that the inside of this here is basically pure copper. Okay. And you can see here there's almost no iron on the inside, no oxygen, no zinc. So this was made from the pure copper of the copper pipe when this overall large tori structure was formed. But its skin on the outside here, firstly, the inside copper is incredibly thin. It's incredibly thin. But the outside skin here is iron. So this is completely continuous iron on the outside here. Okay? And then it's these bands coming out, which we already know are vortical. And if you go through, the striking thing is that, okay, if I can catch it right, when it plays on, let's play it on. The striking thing is that the aluminium is not contained in this skin that skins the copper. Neither is the silicon. The silicon and aluminium are in between the iron bands that are coming out. So it would appear that there is some wave function going on outside of this sphere, but in the actual sphere, the event horizon area, where this actual torus here would appear to be a hollow structure that landed on here that was predominantly made of copper, but it created this perfect skin of iron. Now, was this already iron on here and it instantaneously reorganized the matter? That is possible. That is possible. Or was it carrying this iron skin and, you know, whatever, it broke off? But the interesting thing for me is that the iron is pure iron on this boundary area. And if you actually, I don't know if you can see, but on the potassium, there's no potassium on that boundary area. It's just pure iron. There's no zinc, there's no silicon, there's no aluminium. It's just completely pure iron. The actual skin is pure iron. Okay, so maybe I can... Here, so this is the iron. And on the outside of this overall structure, it would appear that there's a hexagon type field, certainly looking at this boundary, or polygonal around it. And outside of that, it goes straight to the zinc. So this is zinc on the outside here. And this is iron in this area where you've got these crenellations. And it's only iron on the edge. It's not aluminium. It's not silicon. It's not potassium. It's none of these things. It's not the copper even. Nothing. It's just pure iron on the boundary. And it's actually the same on the inside skin. So I actually look at the inside skin here. Here. And again, the iron is the inside skin. Outside that, inside that you have the copper. And then in the center here, you have carbon. So this would seem to be synthesizing carbon in the center here. Anyway, you can go and have a look at this video in your own time. I think it's frankly astounding in terms of what it's showing, the organization of the matter. So the copper here, the iron presented as it is there. Okay. So what we have shown is that it would appear that there are very large scales of clustering, which are sphere and tori, and that both of these structures are hollow, and that on the skin it's this iron, and then out of that there projects these other structures which tend to be predominantly iron, silicon and aluminium, and on the spheres in the water scenario they're slightly different. Okay, this structure that you are seeing here is going to be very important a little bit later in the presentation, but before we go there, I want to talk about the other thing that came up during the presentation, and that the video and the analysis this week, and that was the edge of the ball lightning cut, and that is here. And if I just pause that for now, I'm going to make that smaller, and I'm going to bring up where we are talking about in this part of the analysis, and it was this. So we are looking at this area here. Now, bearing in mind that this piece of copper at this point was actually contacting a large lump of iron, okay? And copper is highly thermally conductive. This did not melt. This did not melt. It's multi-axial, i.e. this is the side of the, so it's like this side here has been cut, but it's been cut that way, orthogonal to the side, or perpendicular rather to the side, yeah? This has been cut and it's left this point here. This point, how did this not melt? It did not melt because it was nowhere near 1089 or 1089, something like just under 1100 degrees centigrade that copper melts. It was not at that temperature. I don't even think it was close to that temperature. However, this 10 millimeter or so diameter ball was cut out in Hent-Uren's experiment. Okay, and we're going to look at this wall here. And what do we see on that wall? Well, here it is, quite zoomed out, and we can zoom in. And what do we see? We see these scallops. And we've seen these scallops on the Hutchison knee sample and in other samples, okay? Here, a little bit closer, different look at it. But we're going to go way, way in. We're going to way in. And here we go. This is on the SED. So you're really seeing the form. This is on the BSD, so you're seeing the elements. So you can see we know that this is likely a carbon blob here. This kind of spherical blob here. It's likely a carbon blob. This is likely a carbon blob. This is likely a carbon blob, likely a carbon blob, okay? But within the actual scallops, there is something unbelievably striking to me. And this area tells it very, very clearly. Okay, what am I talking about? I'm talking about the fact that here and here you have sections where it's scalloped out in this plane. Okay, and here you have it scalloped out almost in a plane which is 90 degrees to this plane. So this is going that way, and this is coming through the field of the screen. Yeah, this is going through the field of the screen, and this is going that way. This is going that way. How is this possible? What is this telling us? How is that possible? And in fact, you have it here, you have it here, and I imagine it's, you know, all over this, different axis of the way that it's being cut. Go right in here. You can see it churning around. This is not copper melting. This is copper being disrupted by a intense flux, which itself is not necessarily, the structure that is doing it is not moving, but the material in there, the matter in there, is forced to move around, okay, and lose its normal structural integrity. It is being disrupted. Okay, is it being converted partially into gas? Possibly. It could be being converted into protons. It could be converted into light and leptons. It could be converting into gases like helium and argon and so on. I think that's quite likely. I think that some of it will be made into very small particles. So this is 5 microns. Yeah. So if that's 5 microns, this is 1 micron. So 1 micron's across there. So these are nanoparticles, okay, that have been removed from this overall structure. So this would dustify material, and it would convert some of the material, I believe, into gases and protons and electrons and light. Okay? This is dematerialization of matter. Okay? Here, you've got this, it's eating through the plane of the screen, and these ones are along the plane of the screen. Yeah, this is along the plane of the screen. How is this possible? For me, this is giving detail to what we saw on Hutchison sample, and I believe I've actually got another sample that I might want to show you at this stage. Yeah, so you may recall this sample from many moons ago, and this is the ball burn sample from John Hutchison. Okay, and this is taken with an Urugo microscope, and this is with an SEM. And you can see this same scalloping going on. I mentioned it at the time. Scallop, 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 scallop. A regular array. You've got the scallops in here. It's the same thing going on with this ball lightning structure. Henk Uren, you have replicated the Hutchison effect. You have replicated the Hutchison effect, but in a very, very different system. I've argued that there is this torus field around here, and this is the focused area, and in the focused area maybe matter disappears and it has an iron skin, but the thing is that this is already steel, so you can't really tell what's what. So, but you can see through to the level of the scalloping in here. You can actually see the pits. Now, is this one pointing this way and this one's pointing up to us? Is it doing the same thing? Look at the pits around here. It's exactly the same thing that we are witnessing on the Henk Uren sample. Exactly the same thing, in my opinion. And for reference, on the ball burn sample, here, this is the structure where we saw this on, but inverted because it was on the other pole of the sun, in a solar flare on the European Space Agency site. And on a video that I said the sun doesn't lie, okay? This is scale invariant. So this is a few centimeters across, maybe. And in the case of the sun, it's several times the diameter of the planet, but essentially identical structure. This is our Yin Yang structure, and we've talked about this. And if you look at the structure on this part at a higher resolution, you get to see exactly the same type of pitting that we've just been discussing. This is this Bogdanovich style vortex structure, and that we've looked at here in more detail. And notice the way that this material is cut here. We are going to see this, and when we see it on the lion sample, you will know 100% that the lion author multiply replicated 4 times out of 4 experiments in a row the Hutchison effect, which is Lena. Okay? So, this is that. Now, what am I saying this is? Give me a moment, I'm going to prepare it. Cheers. Just Cafola. It's not an advert. I don't get paid by them. All right. Give me a second to get this together. I need to load up something. So when people say, no one's replicated the Hutchison effect, everyone who's done Lena has replicated the Hutchison effect. Thousands and thousands and thousands of times. They've all done it. All of them. Oh dear. All right. Okay, I need to load up Lightwave. Where are we? Hopefully my computer doesn't break. It's pretty good, this one. Yeah. Oh, this is just a pleasure. Oh, this is such a pleasure. It's such an honor to be doing this work. Really, you have no idea what an honor it is to be doing this work. Okay, so here is our tori of 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 tori ad infinitum, right? Down to those super micro leptons, okay? Something that's very important to note here, because I haven't corrected the object that I'm going to show you later, is that this is pinched. The field structure requires it to be pinched. This is what we learned from the Hutchison sample. Which Hutchison sample am I talking about? I'm talking about this Hutchison sample. And I have prepared these slides, honest, governor. Here. No. Oh dear, what did I call the presentation? I haven't given it a name yet. Oh yes, I have. Mining sweeping. What am I talking about? I'm talking about where we derived this from, yeah? So we had a whole, there was a subunit that made these bigger ones, and that made this big one. And just like the slightly distorted one that impacted in the Henk-Uren ball lightning cut copper pipe, this also came at an angle, so you can see it's a distorted shape here. It's a distorted shape. But from this, we learnt that there were these toroidal sections that were cut out, and you can see here these very clear toroidal sections. Okay, and when I change the lighting, you can see them where they're cut out. Okay, so this is where we got our 48 from. Okay, and you can see, like I say, it's slightly distorted, and it's where this similarly crashed into the surface and maybe bounced off. And note, I am not and have never said that the structure here is spinning. What it does is when it interacts with material, it moves that material. And we know that 100% because of where it interacted with the quartz in line. It moved the material around the outside. It moved the material around the outside. You have a flow between these poles. And we know that it did not rotate itself. It locked into place because you have a pentagon here. Okay? If it was rotating, you would always have a circle in the center. You wouldn't have a shape in the center. Okay? So we know 100% that these are two different poles, because one pole you get a white blob in the middle, and the other one you get a black blob. So here you've got a white blob and a black blob. Okay? This one's black blob. So this is a cluster of one type of pole, and this is a cluster of a different type of pole. Okay? So mostly I show you the red ones, but you can imagine that they're different. So the red ones are effectively a north pole because they're throwing the material away from that center so it doesn't damage the center. The south ones are pulling the material towards it so it crashes in. So it's the most white area of the damaged fused quartz. Okay. So back to the model. So in this model, I've said that this has to pinch because this is what we see on Bostic and Nardi's paper from 1980. This is what we see in the work of Matsumoto. This is what we see on the Hutchison sample. But note, it's not just pinched in that aspect. These objects here, if I select one of these and hide the rest of it, maybe I can do that. It's a little bit slow because there's a lot of polygons here. Right. Is that going to work? Are you going to hide it for me? Oh no, it's hidden that and not everything else. Selection. Oh dear, it's too long since I've looked at it. View, invert, unhide, hide, invert. Okay, there we go. Right. Oh, where did that go? So this is a single tori of that major structure. And it is squished itself in the same way that the level up from it is. Note also that this is actually a if I can show it like that, has it got a view mode on there? Oh, where's the view mode gone? Oh dear. Anyway, that's up here. So I need to go wireframe shape. This is made of triangles. And for those of you that used 3D software, you can always make things of triangles. And that will become important in the discussion later on. I've not done it with the torus. I've only done it with the sphere. But that will be fine. And we'll come to that in a little while. Okay. All right. So I'm going to now unhide everything. Before I do that, I'm going to go to Smooth Shade and unhide. Then I'm going to go to our full object. So this is our full object. Now imagine that this is just like looking like this, okay? Imagine it's just looking, for simplicity's sake, I'm just making it a simple torus for now, okay? Of the same scale. And we're going to go to our next object here. And it doesn't look any different because this is the same object. I paste it in. But what we're going to do now is we're going to add something around the outside. We're going to add things that are orthogonal. Okay? So we've got a ring of rings. We know this happens. Now, is the ring here bigger and in the center? Don't know. Let's find out. Okay? Now, I didn't bother to pinch this here but this will be pinched because we know from the other one that the field structures have to pinch. They don't like being in on each other. Okay, they pinch. This is what we see in the physical embodiments of the collapsed structure. So, here we go. We have our structure like this, but these will be pinched. So if you were to look at this from top down, this would be a large ellipsoid, but actually it's a torus that's pinched into the center of this torus, okay? And we know they can pinch, as I say, because we've actually seen it in the collapsed coherent matter that we see later. So let's add another layer onto this. Okay, so we get it like this. So when you look at this, you can start to see how you could have some structures being chewed this way and some structures being chewed this way. Yeah? Like we saw on the sample when we go there, when we go here, and we see this. If we can, I need to minimize this quickly. When we see here, we've got some chewed this way and some chewed in this axis. Some chewed this way, some chewed in this axis. Okay? Chew down there. Chew wherever. But they're from here to there. Okay? You understand? That's kind of what we're trying to represent here. We've got things chewing at orthogonal axis to each other. Okay? Now what this does is this makes a very tight structure. Okay? And if you actually look at, for instance, this and this, what are we seeing there? Well, what you are seeing there is the self-sustaining pointing vectors in the bagel game. Just two of them, right? That's what you're seeing there. And what we're seeing is we're seeing a superstructure made of a lot of these. Let's add the next level. Oh, look at that. Isn't that nice? Oh dear, what have I done now? There we go. I'll take the textured wire off. Look at that. Can anyone tell me what that looks like? Are you there yet? Are you there yet? Are you there yet? It does look familiar, John, doesn't it? Now, can you imagine if this was pinched? Because we know it can be pinched. We know it can be pinched. If these were pinched. Yes. Yes, Drav. It is the flower of life. It is the flower of life. There we go. Just extend it out a bit more. Yeah. And so what you end up with is a structure. And we know that this structure is scale invariant. I.e., if you can keep pumping energy into this coherent matter, that you will get a skin that is very tightly bound. And because it's magnetic, it's likely to be ion, I-R-O-N. And in the case of the work of here of Alan Goldwater, this is actually quite thick, but this is a much bigger ball, okay? So this is 100 micron, this is 10 microns. I think this is probably 5 microns, okay? It's about 5 micron. If we go back to what we were seeing on the outside of the cut, the toroidal cut, how big was that? Here, this is 10 microns, this is 5 microns. I would say that this was probably maybe one and a bit microns. Okay? So in this case, you know, I would imagine if this torus got bigger, this inner skin would maybe slightly get bigger. Okay, but it's scale invariant, so it will get bigger and bigger and bigger. Okay, and in the case of here, the skin is here. So this is how you can get a hollow structure. And what does that look like? Well, firstly, I've shown you what the ancients thought it looked like. They thought it looked like this. And they thought it was so important, they decided to use a coherent matter technology to etch it on the Temple of Osiris at Abydos in Egypt, and to put it on the ancient Indian temple lions, which were then copied for the Forbidden City in the center of Beijing, for this structure, which I believe is the flower of life, because this structure takes whatever matter is available to it and tends to produce all of the elements for life. And it produces it in the overall structure produces it in this literally like a fleur-de-lis. Literally like a fleur-de-lis. So what does this look like if we put it onto a sphere? Well, firstly, you have 3, 6, 9. 3, 6, 9. Okay? 1, 2, 3, 4, 5, 6, 7. Oh, okay, wherever is it? It's wherever it is. It's the first 2, isn't it? 3, 3, 6, and then whatever. Anyway, let's not dwell on that. Here's our sphere, and our sphere is texture, and we're going to go textured wire. Our sphere can be always represented by a sphere of triangles, and a sphere of triangles has within it always some hexagons. There's a hexagon there, so we got a hexagon there, okay? And in some places it has to have a pentagon, and there's a pentagon, okay? This is how buckyball are constructed, okay? You can do the same thing with tori. So you can always produce structures out of triangle arrays, okay? Sometimes they need to be slightly distorted, but we know from the physical evidence that we have been able to create distorted tori. We know this is what happens, this is what nature is doing. We know it 100% certainty because we have seen the physical evidence. We didn't need to do a calculation. We saw the physical evidence. So here you've got a pentagon, and around the pentagon you have a hexagon, and 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 you have a hexagon, okay? It does not matter. It does not matter because you can use the same rules when you are building this. So if we have... If we have our structure here, and we put on this, what do we get? We get this. Okay? And what you are looking at there is in the center of each of these points, you have a torus, and then you have a number of links to the adjacent tori. And this creates a structure that can grow. And as more material comes in, it can reorganize it. Now, sometimes you might lose a couple of these links. Yeah, you might if I invert that, you might say not have this one, and you might not have this one. So if I go like that, and I go hide selected, right here, and I lose this one, hide selected, when this presents itself, yeah, when the material collapses, you could have a structure that looks a bit like, not that, and I can go here, come on, give it to me. This, where sometimes you get a full loop, but sometimes the structures that are holding it together are not there, and so you just get this. But remember, inside this structure is a fully coherent structure. So this is material attempting to cohere fully on the outside, okay? But on the inside, it's always completely coherent. Yeah? So on the outside, you have this kind of structures where the material's pushing in, it's pushing in. Okay? And then on the inside, you have fully coherent. On the inside of the torus, you have fully coherent. You've got material being vortexed in. And where is the material being vortexed in? I believe, likely, the material is being vortexed in due to the structure that you see here. So if I unhide them all, okay, if I go actually back to the group shot here, there will be material being sucked in here, maybe sucked in here, sucked in here, sucked in here. If you've got a group of 3 of these sucking in together, or one is a vortex and a counter vortex, whatever, it doesn't, you know, you can work all this out, but I think you get the idea. That then material is being pulled into the overall inner part of the structure, which is going to be completely one homogeneous blob and will only be iron. Okay, it will only be iron. You might have different elements on this side, and you might have different elements on the outside. Okay, and if you can imagine, just like these can link this way, you can imagine also that some could link on this way, and you have a link coming out here, right? And then what you have is a sphere, and from the sphere you have a load of little tentacles coming out. And those tentacles can twist into these twisted structures, these twisted bundles. These little like feelers. And these are these twisted bundles. Yeah? And if this is 1 micron across here, and you have 2 structures in a twisted bundle, let's say, there's definitely one coming around there and another one coming around there. What this means is that then it's half a micron, so the actual wavelength is 1 micron. Okay? Does it change as this structure gets bigger? I don't know. Maybe it's resonantly pumped somehow at this resolution, at this level of coherence. Don't know. And the material outside of the iron is silicon and aluminium. Okay, and then in the far reaches you've got more carbon. In the center, in the particular torus here, you've got a lot of carbon, and you can go and look at the analysis on that. So what I'm arguing, therefore, is that the ancient people 100% knew that the flower of life was ball lightning. If I can get it to come up and stay up. Yeah. And that this is the core of ball lightning. In fact, actually, the core is this inner skin here, that, to be very precise. But typically, you end up with these kind of structures. Okay, and we've seen them in pretty much every system that is able to push to a certain degree. Okay. So is that clear to everyone? Yeah, smooth means fully coherent. The inner shell here is fully coherent, and this inner shell here and this inner shell here, of which I believe is the actual shell itself, and the evidence from this analysis shows that the shell here is just iron. It's just iron. So it's the most ferromagnetic material is iron, right? And it is the densest packing of nucleons. So if you're going to have ordinary matter, that's the densest packing of nucleons, iron 56. Yeah, well, technically nickel 62, but iron 56. And then that is this structure. This is the structure, and that this on a sphere, as I have represented here. Okay, if you can just project that out and correct for the distortions, which we know the distortions can happen because we've seen it We've seen it physically in our data. So this isn't a thing that you need to work out with maths. We've actually seen the physical evidence first, having predicted it, but first. And the prediction came from physical evidence from the Hutchison effect. Okay. So this is a ball, and the ball would have a skin that would be the thickness of this. Okay, if you imagine that on a sphere, yeah, that would be the thickness. And then from there, you get things that aren't fully coherent. There's a braid that comes out, and the braid might be coherent because you've got those things twisting together that are doing this business. If I quit, show that down here. You have these braids coming out here, and because they are tightly bound, they are mostly iron. Okay, but in between and in the boundary between them, you get these other elements. So if I can show the video again. Okay. Yeah, so here this is totally iron. It's not potassium, it's not silicon, it's not zinc, it's not even oxygen. It's just iron, this skin, right? So this is the coherent, fully coherent boundary layer. Then you have these little nodules that come out. And then this, I'm going to be calling this entrained material, okay? And this is going to make sense for the next part of the argument. So let me just see where we are in our presentation. Is that clear? No, it's iron 56. Iron 56 might be a great source for... No. Yeah, filament pairs. Yeah, I believe they're pairs, likely, or they could be groups. Because if you look at Matsumoto's work, for instance, you get these, what I believe are bundles coming out of his thing. So if you look at this particular image, you can imagine that these are the cluster cells here, and these are the gravimagnetic rotors, as is referred to by Solin. And you're getting bundles that come out, and the bundles are twisting together. You can imagine it's a bit like when you go to a beach in Spain and they offer to braid your hair. They get a load of hairs, they bunch them together and then twist them into, you know, a braid or a bit like a dreadlock. And these are all twisted together, yeah. And so we've seen this kind of effect in the titanium exposed to a Mars gas, yeah. And that explosive event with PTFE. And you get these cones which have different elements down the base, and they go out to a carbon tube at the end. Okay? So, do you get how much of an honor it is for me to have been able to observe this sample from Henk Uren, from the Hutchison samples, from Lion? This is just such a gift, an honor, and a privilege to have been able to do this. You know, it is everyone's right. This is not something that can be invented. It is nature. It is nature itself. And the ancient people knew it. They knew it. And the best way that seems to be able to do it is sound. And I am going to prove to you in the next section of this video, if that's where I'm going with this. Let me just check if that's what I want to do. What did I say I was going to do today? I was going to do, right, structure of small clusters, we've done. Structure of the skin of large hollow spheres and toroids, we've done. Entrainment of smaller clusters. Ooh, that's going to be exciting. Right, let's do that. Entrainment of smaller clusters. Right. What you have seen, I believe, already is that we can create a torus, or let's call this the skin of a sphere, which is produced by a yin yang type structure, because you need charge separation, okay, to do this. And these tentacles down here of our plasmoid in motion, as you might like to call it, these tentacles that are languishing on behind, I believe are entrained exotic vacuum objects that are not quite clustered onto here, and I've showed you how they could be bound to the main structure. Okay, I also showed you right at the beginning of this presentation that, or early in the presentation, that in this particular image, which I can go to here, and I will pick it up from here. I have shown you in this image that these are twisted braided structures, yeah, but they're coming out all in a line over here, and then all over the rest of the place it's like slapped down. I'm saying that this structure here actually came in from somewhere up here, flew in and crashed onto the surface, okay? And that just as we saw in that graphic here, where you have these things behind it, that's showing the vector by which it crashed into the surface, and you can see that here. That's this little vector here, okay? So it came in, crashed into the surface. A lot of material that was orbiting around this structure in this field fall off, and we've shown that it has this hexagon type field around it, and we've seen this on many, it's almost so boring to go over, but so many different samples. A really good selection from the Nova reactor, from studying the inside of the Nova reactor, where they have this field area. And you might like this to the fuzzy area that you see around the very pure area in the Vega experiments. So you have this central area in your spheres which has this very tight boundary, and then around it there's this zizzing area. There's this zizzing area. You can go and have a look at the videos. You can go and have a look at the early videos that I shared from Henk Uren's Vega reactor. And this is the zizzing area. This is the area where a lot of electron clusters are coming together and they want to join the ball lightning that's here. But actually what tends to happen is they like to be at quantization level. So you get one ball here, ball of fire here, and another one ball of fire here, and there's all this material zizzing around. And then what happens is when enough of it gets together, it then just bridges, and you end up with a half of a pill shape, half of a tic-tac shape, okay? And then it's all zizzing around the outside of that, okay? So this is the wannabe coherent matter, and this is the sheath of the coherent matter, okay? Individually, these might be coherent matter, but at different quantization level. Okay, so I am going to show entrainment of small clusters, and I think to do this, I'm going to visit a very old image which I shared a long time ago. So, entrainment of clusters. Okay, so this is a whole bunch of torus images, and you can imagine that this is a laser on. If you go to this YouTube link, this is a blah 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 blah. Okay, so there, hydrodynamic model of the Evo. Okay, all right. So the matter is being focused into the loop, yeah, and you've got material from in front, and I've said that you can use this for propulsion because the material that causes inertia and mass is the relic neutrino condensate, in my view. This can go partially. This can kind of like go through matter, but it can also bounce off dense matter. Some of it will be reflected, as has been shown by Alexander Parkhomov. And so if you have something that is able to sweep it out of the way, then it removes and moves the material almost instantly around so that it's not causing inertia to the thing that you would have in the center here, let's say, in the dead zone, yeah, in the center, okay? So this would be, for instance, how your ARV might be propelled. And I'd first observed these kind of toroidal structures clustering and moving and able to move through water much faster than the drift of the water You know, you can see all these particles drifting around, but they're barely moving. But these vortex structures are able to move incredibly fast through the water. Okay, this was very, very informative. And you get this soft area and this focused beam. Soft area and the focused beam. Yeah? Okay, so why am I showing you all this? Because of this very, very important section. So this is actually taken from one of these videos. Okay, and I've blown it up here when I get to it. Firstly, you can see there's a wave function on this torus. So this may be something similar to what you saw on that torus that we saw in the Vega Valley Eastern Plateau, where we had those kind of 3 bright spots and the dark spots. You can kind of imagine it something like this. But it's these areas where this is moving through the water this way, down to the bottom left of the screen. Okay, so this is ultrasonically driven hydrodynamics. In 2017, the day after I gave my red pill presentation to IIT Mumbai, and only because of that, I was able to go and visit the lab of Suhas Ralkar. And it was absolutely transformative because I got a sample and that showed the first strange radiation and I was off to the races. So when you look at this video, you can see that there are these feelers that are coming out, but they are going around the vortex this way. And because material moves faster around this outside, like it's moving faster around this outside, like it's moving faster around this outside, like it's moving, this is actually from one of these videos, the thing travels, and you can see actually on this installation here in I think it's is it Norway? Oh, no, I think it's in Denmark. You can see the material's going around on the outside, but it still travels in this direction. It's not just because it's hot. That's what they do, okay? So it travels around in this way, but material is swept around. But when you look at this in higher resolution, this is absolutely stunning to me because these feelers are themselves vortexes. So you've got a vortex here, you've got a vortex here with two components. There's two components in here. Now I'm going to go and get this image specifically so we can zoom into it. Yes? So let me just dig that out for you. Okay, here we go. So, around the outside, you have a vortex here of a pair. Okay? You've got a vortex of a pair. You've got a vortex of a pair. Semi-distance between them. A vortex of a pair, vortex of a pair, vortex of a pair, vortex of a pair, vortex of a pair. Coming into the outside of this structure. Over here, you can see on the far side, you've got a vortex coming into the outside of this structure. So, well, it comes into the inside. Okay, it comes from the outside into the inside. So this is telling you that within this torus structure, there are something going on here which has a regular quantization, which is able to pull in its own vortex structure. Okay? This, I believe, is very similar to what you are effectively seeing when you are looking at what we showed earlier. Let me get that. Here. These vortex pairs coming in. And you can imagine that these might be the kind of strange radiation things that actually is strange radiation caused by a exotic vacuum object traveling, and behind it, it's trailing these things. Well, maybe that is exactly what's happening. Maybe that is exactly what's happening. Now, I'm going to go to another sample that was provided by Suhas Ralkar. And this is the fuel where I observed the strange radiation coming from. And after I'd done that and it'd been with me for many months, I went and looked and I found these spheres. And from the spheres, there was this beam, a slightly wide beam of tracks And from each sphere, you had these tracks. There's a whole bunch of them here. One track's going over that way, one track's going over that way, one track's is going over that way. And it's all around the periphery of this area where this material here is broken away or whatever, for whatever reason. Okay? And here's this structure with the tracks coming off. And this looks remarkably like our tribe's image of the structure. Okay? So now you might understand why I thought about that. Okay? So if you actually look at images of plasmoids traveling through on video, there tends to have this ball that's going forward that has this maybe slightly domed front, and then behind it has this trail. And I think that's exactly what you're seeing here. It's exactly what you're seeing here. You're seeing something that looks like a bit of a ball with a dome in front, and behind it you see a trail. And they're all the wannabes that want to be part of this coherent matter. They're being dragged along. They are entrained. They are entrained matter. Now, why am I telling you this? Why am I telling you this? So, I think we have done entrainment of smaller clusters. Okay? There's a lot more material I could show you, but I think that's probably enough. Okay? And if we go down to is that all I want to show on that? I think that's clear enough. I think you can see that the torus is pulling those in that are vortical, and that's exactly what you see from the ultrasonic water tank to the plasma toroidal strike on the Henk and Vega. So we have Suhas Raukar's ultrasonic water tank visually capturing those tori moving through water, a well-ordered structure that is pulling in vortical, regular, distanced vortical pairs into the torus structure. Okay? So you have a water hydrodynamic system and a magneto-electrical hydrodynamic system. But as I've argued, because you get charge separation, because you get easy water, because you get all these things in water, it is also a magneto-hydrodynamic system. They are the same thing. They just look different, but they're not. They're the same thing. And so we've synthesized the crenellated spheres using the water system, as you can see here, by the excellent work of Alan Goldwater. And we have synthesized them in the Vega Valley and other systems over the years. And natural ball lightning produces exactly these structures. Not slightly different, not like opinion might vary. No, it's exactly the same thing, right? So natural ball lightning is doing that. So I think we can move on to reason for strange radiation tracks being easier to detect with polarizing filter. Now I'm going to leave you there for a second whilst I go and visit the little boy's room, and you can talk amongst yourselves. Okay, there is actually something I want to share with you, which I didn't share with you on the subject of entrainment, which I think is important to talk about. And that is here. If you remember, on the Lion reactor, we had this 12mm structure, and it had two very clear structures, and that there was a flux loop that came down and collided with the top of this Cantal wire, and it's not on the underside, so we know the flux loop went in that direction. But when we use the microscope, if I actually show you what I'm talking about here, this is on the Lion reactor as well. Okay, so this is not the core, this is on the quartz liner. So this was 12mm across, just to go over it again. From the center here, you had a vortex flux loop that came round and hit the structure of this Cantal wire. There's like a storm on there, and there's synthesized calcium in there, which is not in the materials here, and not on the underside. So we know that this came over there. And you have a vortex this way and a vortex this way, and you can see a little bit of the vortical nature here. But when we looked at this on the microscope up close, this vortex or side has vortex pairs within it, or rather it has little vortices within it. So this overall structure is bringing in smaller structures and bringing it in, and it's kind of like, you can imagine these as little tornadoes, and this is a hurricane, or the fact that they're all part of the same self-similar fractal structure that we saw. And so what is going on with this, bringing in material from the outside in vortical pairs, structures, is probably exactly what is going on in here. But this one, you didn't see it happen, whereas in this one, you could actually go and watch the video of it occurring. Okay? So I think we're now ready to move on to the... No, that's later. let's go back a bit, shall we? Oh, dear. Not there. We're going to do that bit in a little while. Entrainment of clusters. Here. Okay. All right. Fine. Reason for strange radiation. Tracks being easier to detect with a polarizing filter. Okay. Okay. So, you will recall when I took this Dynalite Edge 3 digital microscope to Japan, it has this polarizing filter on here, so I can change the polarization here, and I speculated that this might make it easier for us to pick out features. And on the very first night, having got access to a sample, you will remember with this video that is linked here, that when you looked at the sample without the polarization, you basically couldn't make head nor tail of whether there was anything interesting to look at. And live on camera, as I did it from the center of this vortex spot, if I'm actually showing it to you, that would be helpful. Right, so I'm talking about this. This was no polarizing filter. You couldn't make head nor tail of what was going on. And here you can see the Dynalite here. You can go and watch the video at your leisure. Down here on the vortex spot, coming out of the center of that, there was this helicoid trail marked on the stainless steel of the metal. And it was just like, boom, it works, done, excellent. And one of the examples was this one, which I shared in my Azizi presentation in 2021, where this is another stainless steel Amasa, Roishin Amasa, Dr. Roishin Amasa vibrator plate, and you had this vortex structure, which looks like it has at least two substructures to it, but maybe three. And we've shown clustering of 2, 3, 4, 5, 6, 8, and all the way through to 48 at various different levels. So the fact that this has 3 or 4 or whatever, it doesn't really matter. You've got this periodical component here, and this is in David Boutilier's experiment, and this is 4 frames of, in my view, a coherent matter traveling. And the reason we see this is because it's either cohering matter from the low pressure plasma around it, or it's ionizing the material as it goes through, and it's losing a little bit of energy as it came out of a large coherent matter structure that had a Coulombic explosion, and it threw that material out. produce this structure. Again, you have the periodicity here, the periodicity here, the periodicity here, and this is one of these structures, I believe, with the periodicity here, here, and here of a coherent matter wave, and this is like diamond, and it has material that it either entrained within it, like you see on the balls and like you see on the tori, or as it collided across this copper oxide surface, which is lovely and nice and homogeneous copper oxide surface. It just grabbed a bit as it was going. But anyway, so you see a witness mark, you see a in progress on video captured structure, and you see a collapsed coherent matter diamond woven structure, as you can see this weaving. So you actually can physically know what these structures look like. Here is an example. Now the thing is, why do we see this material causing being able to be viewed by using a polarizing filter? Why is that the case? Well, I think the answer is I've already given you, and it's maybe not obvious to you, but let's go and have a look at that. Why do you think that is? Why do you think that is? Bearing in mind, we know 100% certainty that ball lightning produces these iron-rich crenellated spheres that look identical to the iron-rich crenellated spheres that was produced in Ultra experiment, the one conducted by Alan Goldwater in Santa Cruz in California. And we know the same exact structures form ad infinitum in the Vega Valley experiments and other experiments that have been conducted by the MFMP and other parties. Okay, so we know with certainty that that happens. And it would appear that the tori are the same thing and that they produce these things, okay? And I've said that what you are looking at here is as the tori was coming down and slamming onto this surface, as it was slamming onto this surface, and that the rest of these things around here are just the mishmash of things that flapped around the place. They went like that, and some of them collapsed and they left the iron that was in their substructures around the outside. Okay, so why do we see this polarization? Well, I think it's rather simple, but before I want to go on that, I want to show you something which is absolutely mind-boggling to me. The level of synergy between the Vega and the system, the Ultra system. And it's this. You may recall some time ago that I shared some images that I captured on my first SEM session in Prague a few weeks back. And what I did is I took some distilled water and some household aluminium and I ran it for 90 seconds. Yes, this experiment was a whole 90 seconds. So for those people that, you know, want to get into this and they've got a spare $35 or maybe $5 if they sell the device afterwards, and they've got some kitchen foil and they've got some water, hopefully you've all got some water, you can spend 90 seconds of your time running this experiment and maybe you'll see this. Everyone can do it. It doesn't matter if they're 5 years old or whatever. You know, 5 to 95. Everyone's welcome. Oh dear. And what we found was, in this experiment that I did, I spent a whole 90 seconds on it, is that, oh, I've revealed the money shot here. This is at the point of a crack forming on a Ultra experiment. So on the point, something is going on really weird within a defined zone. Okay? And matter is starting to disrupt in weird, strange ways. And here's another one. Weird, strange ways. But however, over here, you've got the grain of the rolled aluminium here running this way. But across the grain, you have these vortical spiral structures with gaps in between. Vortical spiral structures with gaps in between. And you know what? They are basically exactly the same size as those in the Vega experiment, the copper tube ball lightning burn sample, okay, with vortical structures, with gaps in between, This is 10 micron, this is 20 micron. I've scaled this 10 micron to meet the 10 micron here. This is basically within, you know, very small distance, the same structure going on. This is within the hydrodynamic ultra system. This is within the plasma system. And effectively, this is a magnetohydrodynamic plasma system, although it's water and an ultrasonic device. And this is a magnetohydrodynamic plasma system in the Vega apparatus. You have the same thing going on. And it's not just there. I like this because this is a strike mark. This is a vortex itself. So you have the shape here, you have the two incoming structures, and you have them orbiting around each other, okay, and coming out here, right? So these are like you saw in the experiment that I first witnessed in 2017 in Suhas Ralka's labs, where you got these two vortical structures, okay? But just touching the element, and by the way, in this case, and again, this is to scale. This is 10 microns, and I've taken it and scaled it to that. They're ballpark the same size structures, okay? This is ballpark the same size structures there, okay? If I can get it on screen at the same time. let me shrink that one down a bit. Okay. So you can see it actually occurring at the head. Now, the head of one of these cracks is typically where you see these kind of fuzzy grey stuff going on, which is a bit like the fuzzy stuff that's around the coherent matter in the Vega experiments of the balls that you see there. And so what I'm saying is there's nothing over here, and this is in these structures are not only kind of in line with the rolling, but they go off an angle here, and this comes round in a curve. It's not to do with the line of this material. This is the line of the aluminium, and it's crossing the axis, and it's almost not quite but perpendicular, but it's getting close to it. Okay, so I believe that this was a pair orbiting round of coherent matter synthesized in the ultra experiment, and when it interacted with the aluminium foil, it gave a shadow of itself. And this is what's happening here. And I believe that that is exactly what is occurring in here. In this, the fact that this is coming out here, you have a vortical structure, a pair, and it's twisting and it's leaving this track, and it's leaving the track by altering the structure of the matter into these lines, okay? This is coming along here and altering the steel instantaneously. Absolutely instantaneously. It is not perturbed by the fact that it is interacting with dense matter. It is not perturbed. The periodicity between here and here and here and here is basically the same. So it basically does not care about this matter, but it leaves its mark behind. It leaves its mark behind, I believe, by doing something like this material, which is coherent matter, entrained by the big, large object, is leaving these marks. So this is a pair. This may be a pair. It may be just a blob that came in, but you can see on it. We've seen this all over the place. Where it interacts, there is 100% effect. 100% effect where it interacts, and 0 effect outside of the boundary of the interaction. 100%, there is an event horizon here. In this case, as this comes through, there is an event horizon. In fact, you can almost see the twisting of the twists. Within the big things, there's almost a braid. You can actually see the twist on here, right? It's twisting the material around. An event horizon here, 100% effect and 0 effect outside. It's highly, highly localized, the disruption of the matter. Highly, highly localized. Now, why am I making a big point about showing the fact that these have these lines? and the fact that it seems to be the same across extremely different systems. It's because of this. Give me a second. Just need to get something for you. Is that clear? Is that clear what's going on? I think very shortly you're going to know 100% that this is occurring, that this is why you can observe strange radiation tracks on metals and that aren't completely destroyed. Like if it punches a hole through it, then you can see that it's there, then it's done something. But when it's affecting metal in this way, and you can observe it with what do you call it, the polarising filter. So I need to go to my notes. Okay, nearly there, nearly there. So as I said earlier, this is 5 micron. Let's say this is 1 micron, okay? Then the thickness of this outside area is what, 1 micron. Notice that just like on my supposed proposed model, you have a curve and down, and a curve and a 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 down. This, I believe, is these structures of the self-sustaining pointing vectors, the magnetic flux loops that are interwoven into this flower of life type structure on the sphere, okay? And again, this is 1 micron. So the width of here is 1 micron. And you can clearly see that there are 2 structures at least within this thing. So if 1 micron distance has 2 structures, then the wavelength of an individual structure, I would suggest, is effectively half a micron. Sorry, the diameter of one of these structures is half a micron. But for it to be on and off, it's 1 micron, again, as it were. So effectively per millimeter, you have 1,000 of these structures, but at least you have 500 of these twisted pairs. Yes? Okay? Why am I going on about this? I'm going on about this because a diffraction grating here is typically 1,000 lines per millimeter for good quality diffraction gratings. Okay? Which means it has 1,000 lines. You see how easy this is? I wish more people were doing this research because there's so much low-hanging fruit. There's so much low-hanging fruit. So, and a diffraction grating produces, you know, effects that affect light differently. Yeah? Does that make sense? Is that clear? Effectively what is being created instantaneously as a torus in this case, let's say this torus here that we're looking at here, this, if I go out and look at the bigger image here, let's say that our torus here in this image was skirting along the surface of a piece of metal with its coherent matter here, which may not have many entrained pieces. I mean, look at, like, you've got spirals here, and the spirals are fanning out, and the spirals are becoming big spirals. Yeah? You see how obvious it is? The spirals are coming out, and because the radius is getting bigger, out here it needs to be bigger spirals. And of course, when you get so far out, it's just flailing around. They're just flailing around and they're twisting around and chopping into each other. Okay, you're seeing it in the video with the hydrodynamic system. You're seeing it here. Now, as this interacts with normal organized matter, it reorganizes it instantaneously. And if it's moving over a surface, and even if it's just a sphere or a toroid with the coherent matter structure, as it goes and bounces on the surface, it goes bounce, 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 it's going to leave a series of lines that point into the direction. In the case of this, you have two structures that are orbiting around each other, at least two, and they are moving in this direction, so they sweep out the motion, leaving the matter organized by the intense structure that it's comprised of. And because of the peaks, the twist, and the gaps in between, you are effectively creating a diffraction grating. It's a diffraction grating. That's what it is. And so when the light hits your surface, when the light hits the surface, yeah, when it hits this and when it hits this, you get to see the strange radiation track. And it's as simple as that. It's that simple. It's all basic physics. It's basic physics. You can go and buy a diffraction grating for like a couple of dollars and explore diffraction. If you've got a polarizing filter on your real camera, you'll know what I'm talking about. And that is why you can see these tracks, in my view. And the systems don't lie. They're telling you exactly what they do. They're telling you exactly what they do. Is that clear? Right, good. Right, the next one we're going to do to close this out is to make it absolutely 100% certain that these coherent matter structures can self-exist and they can disrupt materials long after. Now, I'm not going to go over the snowballs on cobblestones, where in a Marsa treated 10 yen coin, we saw on a substructure of a substructure of a substructure of a big coherent matter structure, which is where the main action occurred on the outside periphery, that within that bowl there were these things that look like cobblestones, which are not so dissimilar to this, by the way, right? But on the individual cobblestones, we saw little spheres that had started in a little bit and moved around. And as they'd moved around, they got bigger and bigger and bigger, consuming oxygen from the copper oxide on the surface of the copper and synthesizing sulfur. Classic ball lightning transmutation. As ball lightning blows up, it produces sulfur from two oxygen 16s, goes to sulfur 32. We observed that, but I believe that was occurring over a period of time after the initial experiment had ended. That, in one way, is proving this, in my view, has been proven beyond a shadow of doubt for a long time. So the fact that John Hutchison and people have said that his materials are still changing long after, the fact that John Dash observed this, that Savatomova observed this, etc. This is all the same thing. It's all linear, it's all coherent matter nuclear transmutation. Okay, but I'm going to show you something we've already observed on the inside of the clamshell of the supernova reactor. And then I'm going to show something which I'm very glad to say that was observed by Artifact, having accepted the challenge earlier in the week. And I'm just going to go to that. Right, so self-evident. When I mean self-evident, you don't need a maths equation, you don't need a PhD, you don't need a big institution, you don't need to be a military powerhouse, you don't need to have to believe that the science is real. What you see on the screen is exactly what nature did, and it is obvious what it did. It had to have not done it in any other way other than after the experiment. Okay, this is going to be clear, right? So, we're going to come back here, and we are showing you, as we showed on the ball burn sample from 1986, that there is this structure which has a pentagon in the center of this overall largely spherical structure on the clamshell here of the supernova reactor. That it is bored away some of the aluminium, and it has left these what look like these kind of like buzzsaw type sections cut out, just as we saw on the sample which I was showing you earlier. And for those that weren't here, I'm going to do it just for thoroughness. If we have it here, do we have it here? Did I put it into this presentation? Yes, here. So around here, you have the bit that comes in this very important Paisley type 6 structure, and there will be a 9 structure, of course. And you can see these cuts, okay? You can see these cuts. So you have something that's cutting in, and it has these areas around it which are signature of the process at work. So the same thing we are observing in the ball lightning transmutation device called Supernova. And here we can see there's this pentagon in the center, and there's this distance here, and there's this what looks pretty much like a sphere. It might be a sphere or a torus type shape. There's something where it may have come in here, this trail, and you can see that on the video. Now, I've argued that these type of structures, bearing in mind this is aluminium, the same kind of thing occurred on the Hutchison effect, what I call the sword in the stone, because actually the Merlin sword was placed in an anvil. So you had a steel into probably a large lump of iron, so 2 types of metal, dissimilar metals. And I have argued that around the outside of here, on this material, or likely actually on the paramagnetic aluminium, doesn't matter which, when this sword, as it were, was resting on top, it basically sank in because you had these kind of structures all around it that were chewing their way through the material and allowing it to fall into the material. Okay, and if you actually look at the sample on a microscope, you can see that you have this around about a 242 micron gap around where the material looks like, and if the owner of this is happy to have me look at it under the SEM, I suspect that this will be largely carbon in here and the usual suspects. So the aluminium will be converted into that. And we looked around, we found 2 of these cutters here and here. And I would like to confirm that under the SEM. But you can see, given that this is 242 microns, this is 215 microns, that I would imagine this is the same gap here. This is the same gap here. I would imagine that this is around about 400 to 500 microns across, 400 to 500 microns across. This one is cut both into the aluminium and a lot into the steel of the knife. This is cut into the aluminium and the steel of the knife, more into the aluminium on this one. With the central hole, this one kind of has a central dark spot, but not quite so clear. Okay, right. So now I'm going to show you what was seen by Artifact, and again, well done, Artifact. Just check I've done everything I wanted to do today. Okay, yeah, okay. So, where am I looking for it here? Yeah, I got it in Photoshop, haven't I? Good. Where is it? Okay. Actually, before I do that, I'm just going to show you one particular composite here. I did it a long time ago for another presentation that I never got around to publishing, but I think it's nice to put it in here now. Talking about this hexagon field around a central structure is what I'm going to be. Where's that gone now? Oh no. Okay, all right. Where's the layers down there? Okay. All right. Not that one. Okay. All right, we can do it like this. All right, good. So what you're looking at here actually is a structure that is basically identical to one that was found in 1993 by Takaaki Matsumoto in his cold fusion experiment. It is so identical. It's the same size. It has the same essential structure, the same distance between every component. It's basically the same. But in this one, you can see the hexagonal field fall off, which is very similar to that which you see in the toroid that collided with the side of the ball burn cut out of the copper pipe in the Henk experiment. And I'm going to try and match up to see whether the ratio is the same. I suspect it likely is, because these things are scale invariant. Okay, so if you actually look at this, I've overlaid here some magnetic balls. In fact, if I turn that off, you'll see what they are. So you don't have a zone in the center. Then you have these magnetic balls around the outside and these magnetic balls around the outside, and they arrange themselves in this pattern. And if you look at the field here with something that represents the field, maybe that's not the best one. Okay. You can see how this lines up with the substructures of the overall thing. And then I maybe got it here. Is it that one? I don't know. There we go. I don't know. It's getting messy now. Oh dear. How did this come in to start with? Is it that one? Oh dear. Anyway, you can see I didn't want to show this tonight, but I am showing it for the sake of it. Okay. Which one was I meant to be showing? That one? Yes. Okay, so you can see how the balls overlay like that, and the field structure overlays like that. Okay. And if you trace these points out here, you kind of end up with maybe making the hexagon. I don't know. Anyway, just thought I'd throw that in there as a random thing. Let's go back to what I was going to show you. Just because I had it in Photoshop. Now, where is my image that I had in Photoshop? Give me a sec. I've got millions of things to show you. It's sometimes not so easy. Okay, I think I found it. It's just being slow. Where's it pulling it from? Ah! I think I might have pushed my machine to the limit. Come on. Yeah, Photoshop is frozen. Okay. Okay. It's not finding it because it was connecting to a network drive. So I'm going to have to rebuild what I was going to show you. Oh my, come on. Sorry about this, guys. Right, maybe I can pull it up and adjust it. I know there's a problem. Okay. Oh no, it's going to do. Okay, I'm going to have to find it locally. Sorry about this. I had that all nicely prepared, and now it's not going to work like I wanted to. Oh well. We'll have to do it real time, won't we? It's not so bad, I guess. I'll do a filler for now. Why not? Let me do that. So there's not too big a gap. On the other video that I shared with the lion video, there were several other things which were very worth discussing. And I think probably the most important was this. It's a couple of things. This one is, I noticed on the edge of the Lion reactor. Okay, that's fine. On the edge of the Lion reactor, there was this structure, which you can see here. And this was a frozen in place magnetic flux loop. And we have seen this on the Hutchison fracture sample in Magic Incarnate, where you see the two sides of the flux loop meet, and it's got carbon from one side and aluminium or whatever, and it ends up synthesizing elements in the point where the two flux loops meet. And this, in my view, is similar to coronal rain, where the matter comes up and then it rains down from the central point. This is, again, like a solar prominence, and I discussed this in my original video for the Lion reactor, where, if you recall, he put the Lion reactor into this biscuit tin. We found these X-rays, had these, I assessed them to have two spots, and that there must be some flux loop, very similar to a soliton, and that it would look something like this, like a solar flare with the vortex twisting between it. And then I later explained that there was a magnetic core, and the clusters would form at the end of this iron rod. And anyway, 3 days after I made the prediction that this would occur, I found these mirrored structures that would account for the observations on the X-rays. So coming from this point, and this is about the point where the bolt finishes. So where the clusters will be made is on the end of this bolt. Okay, so they would be made, and when it goes past the Curie temperature of iron, which is 769.85 degrees C, they will be released. They would self-organize, and some of them made it to the surface. The north and south poles were at different distances in some cases, and this produced the flux loops. And that we saw these flux loops here, where you literally had a north coming out of the surface and firing its material over, and they had north pointing directly up. And so this one, for instance, would be producing one of those marks on an X-ray. Okay, so, and we've talked about that and so on. So, but we'd never caught one on the Lion reactor before, because I hadn't looked at it since February 2018. And so this was the first opportunity, and within a few minutes, you can see on the video, we captured this structure here, and we've got it in various different ways of looking at it. And we also captured one of the cannons, not the cannon I just showed you, but you can see here, this is a cannon jutting out of the surface. So you have a pole in there, and that's firing the material. But for me, this was a huge win to get this structure captured of this of this magnetic flux loop in such total beauty, in my view, was a real win. Okay. So we got the cannon on its own and a full flux loop. And this, by the way, is CuO, which is cuprous oxide. Inside there was cupric oxide. And inside there was a different structure, which I will look at now, before we go to the money shot, because I think I know where it is now. So I can talk through with you. And that is this. And it is a torus when it comes up. Let me just, yes, my Photoshop has come to a halt because it's trying to find something on a network that isn't attached. So let me just see if I can, dear, sorry about this. Okay. No. How tedious. I'll look at some of your questions until this has come up. What was the Lion reactor? Couldn't find any videos on it. Go to MFMP's YouTube channel and look for the Lion reactor. So I'm going to open this up here. And just in the search time, type Lion, and you will see very large numbers of videos referring to Lion and various analysis of it. Look at mining diamonds with Lion, essentially. Hi, Daniel. Right, I'm going to have to actually kill Photoshop because it's trying to find something I can't show. Oh no, I can show this now. Okay, all right. So this is another. This is inside line, line 1, and your vortex is coming around this way, which is the same kind of way as it is on the Hutchison sample. You've got these sawtooth sections coming out, not quite as clear on this one. Again, this is coming through at an angle. I'm going to overlay our torus on the top, so you can see the most disrupted area is kind of a distance in, and then you've got the paisley here, but it's not so well refined as it's coming in here, and it looks like there's material removed from the outside, so inside here. So this might be a cavity, and actually this was coming towards the screen, yeah, towards the screen, and this is all copper and oxygen. It's actually Cu2O, cupric oxide, and you can see there's zero crystal structure. It is completely homogeneous, and the way you achieve this is to cool it at a faster than 1,000 degrees per second. And when we looked at the data, when the Lion experimenter added a 20-watt halogen bulb to the metal bolt that I just showed you earlier, the bulb lit for something like 30 minutes when it wasn't connected to anything and the power was off, and for 2 seconds he heard an incredible crunching, cracking sound, and I think he disrupted the coherent state in the copper oxide structure, and it instantaneously froze this from, and if you look at the data, it goes from something like 850 degrees centigrade on the proxy thermometer, which actually was likely at over 1,000 degrees, and it went to minus 273 degrees centigrade, or as near as the accuracy would allow, in almost instantaneously. And so this is what you would expect if you had a lot of exotic vacuum objects, that it got rid of their thermal energy as they were cohering, and then they blew up, producing this cold electricity effect where electricity comes out, but the electrons and the ordinary matter need to regain their thermal energy, so it froze the thing. And so that is, in my view, why you have zero crystal, and it is absolutely featureless. It's just pure cuprous oxide, Cu and oxygen, okay? Cu2O, cuprous oxide. And this is an exotic vacuum object, in my view, that was in there, and it came through. You can see it has the D4D ratio, but it's coming at an angle through the structure, and behind it, it's got a vortex which has consumed some of the material that's in a chamber behind there. But as it came through, it split the material, and if I can show you in here, there's actually a whole bunch of images, so you can actually see it at a big distance. So it's actually here. And so we can zoom into there. You can see, like, so when this came through, it split this huge amount of cupric oxide off. And I'm going to zoom in a little bit further here, so you can see I'm a little bit clearer here, and we can zoom into that. Okay, and then we go into the last image here, and then our thing over the top. Okay. All right, so that is one Evo, but this exotic vacuum object does not show us that it was acting after this cupric oxide froze into this glass state. Okay, this, you could maybe argue, does show a north and a south pole flux loop. It left material, it was sweeping material, and then it cooled, and then it just left it on the outside, but you still can't say 100% certainty that that is what happened. However, I believe we can with another sample area, which we didn't see initially, but I did find afterwards, and also Artifact found it. So I'm just going to get that now. And this will be a money shot. And I will need to adjust it, unfortunately, because I haven't got it adjusted. Or maybe I have got it adjusted here. Let me see. Oh, I did. Oh, I did. Ah, ha, 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 ha. I saved it here. I'm not an idiot. I mean, I'm quite an idiot, but not completely an idiot. Okay. All right. There we go. So unfortunately, YouTube smashed this a bit too much. And this was the area. And I started talking about that there's something on screen. And unfortunately, we are in BSD. So if we go down here, this is backscatter detector. And backscatter detector is not very good at showing the relief and the 3D nature of it. It's more showing that this is carbon and this is cupric oxide, okay? But that being said, it was sufficient enough on review of the video when I was editing it to see this structure here. Now, what are we looking at? Bearing in mind, this is 80 microns, okay? This structure here. So we can see we have our glassy plane of our frozen at splat cooled, faster than 1,000 degrees per second cooled area. And then there's this structure here. It's not maybe so clear for you to see, maybe not clear for you to see, but we have almost like a pentagram here, like we saw on the shell of the supernova reactor. We have a toroidal structure, and we have, it's eaten a track in here, okay? Now, I've adjusted the different luminosity and so forth here, and contrast, and more so here. And you can see the pentagram much more clearly here. And you can see these on one side here, maybe it's not clear, but here you've got the vortex, sorry, the sweeping and the sweeping and the sweeping going that way round. And on this side, you've got it going the opposite way round, that way round. And so this structure entered from over here after the reactor had frozen, and it continued to mine into this area with this very small fall off. Okay, this is the boundary of the structure. And this is the material that's being lifted up here, okay? It was mining in there. Now, if I haven't got the scale, I can quickly get the scale. And so if I grab this down here, where's my tools? I'll make a clone of this. Can I do that? Is it gonna? Oh no, it's not going to do that. Ah dear. Why is it not going to do that? Let me do that. Put that up there. Right, now it's not going to complain. You can capture that. Are 80 microns here, and I'm going to make a clone of that. Layer by copy, and we'll move that up there, and we'll put it in a layer above. Honest governor, and I'll move that over there. So you can see that this structure here is almost exactly 40 microns. What did we say the structure was on our Lion reactor? And sorry, on our this one. It's a lot smaller than the one here. This is more like 400 microns. Okay, so it's a lot smaller, but it is 40 microns, and so I will be able to go in next time, because I know exactly where this is. You can go and see where it is, because you actually have the preview window, so you know and I know where this is. And I will be able to get this in absolutely beautiful detail. Okay? And I believe we have a pentagonal exotic vacuum object which was self-sustaining and able to mine into this material after this structure had frozen. Okay? Because if it happened when it froze, it wouldn't have moved. It wouldn't have mined in here. Now, the question is, the material that it mined out of here, did it convert that to electrons, some of it, and light? If it did, then that might explain why the Lion author was able to light a 20-watt bulb for 30 minutes. Because matter was being converted to electrons. Matter was being converted to electrons, destroying matter. And if that is the case, we know 100% that we can use one of these coherent matter structures to convert matter into light and leptons. And the leptons we're interested in for our universe that we live in right now are electrons, and light would be good too. But if this is the case, you are precisely seeing how it is doing it. Regardless, I believe that this is 100% proof that a structure self-sustained after the end of the experiment and persisted to do something to the matter in that experiment. And where have we seen that kind of claim before? We have seen it here in this paper, which I will get for you. And it is not there. It is where? Give me a second. Okay. Bogdanovich, Nuclear, Moscow Engineering Physics Institute, National Research Nuclear University. Video recordings of long-lived plasmoids near objects exposed to remote and direct effects of high current pinch discharge. This is water with shear forces going onto a piece of metal, and they have the discharges going through. This is very similar to what was occurring in the foil production system of Suhas-Ralkar, which I've discussed that greatly. We have a pinch over here, but we have a torus here, which is basically black, and this is preventing light from traveling through it. We have these string-like structures waving around. We have a ball lightning-like structure, and they've also shared color images of these. These are ball lightning-like structures traveling around, luminous plasmoids at different moments of motion from the discharge. The white circle highlights the image of a moving plasmoid at different stages. So something happened here, then it came here, and then it came here. So they've combined a few images there. So they recorded long-lived, so here it is. The study of the surface of metallic electrodes that were exposed to plasma discharge flow, whatever, discovered the presence of luminous spot areas on the surface whose illumination has fairly long duration, over 2 days. And we've talked about this 2 days number before in 2 other different areas. But here is the plasmoid. This was a luminous toroidal object that performs translational and rotational motion over the surface of the electrode. This is up to 2 days afterwards. They videoed these things moving around. That, I believe, is the functional equivalent of this. Okay? It's the same as this, moving around. Okay? And in this case, this is, in my view, proof 100% that this occurred after the freezing of the cupric oxide. There's no other way that I can perceive that this occurred. Okay, and now we understand that these structures can self-sustain for days. Then there is a potential for consuming matter with a coherent matter structure and converting it, in my view, to light and leptons, as well as probably gases and other carbon and things like that. Okay. When you understand this, you can understand why plants love to grow after a thunderstorm. Right? You can imagine that life is so energized after a thunderstorm because there is probably trillions and trillions and trillions of self-sustaining charge clusters that are producing nascent fresh elements. You know, it's just a marvel what nature is doing. Here obviously is a cluster, and we've talked about clusters to the nth degree in this presentation. Here is a plasmoid interacting with a dielectric surface, and it's sending down a beam. We have seen something similar in our experiments, and I believe what you are looking at here, and I said I would do this at some point, here's our dielectric surface. Let's call this glass. This is our plasmoid, and what's happened is the core of the plasmoid has gone through the glass to the other side without making a hole in the glass. This could be ball lightning, but the neutral part of ball lightning. This could be a bunch of atoms, ions, electrons, and cold neutrinos. Let's say it's the itonic cluster of Takaki Matsumoto, where the whole structure is neutral, despite the fact it's got a whole bunch of neutrons in there, a whole bunch of positrons, electrons, and neutrinos. The positron, electrons, and neutrinos bound together in an iton, forming a cluster that goes over the nucleons. And when this collapses, it forms ordinary matter, but it can actually go through and it can get re-excited. So you can have ball lightning that glows, passes through your dielectric surface, which is glass, comes out the other side and then gets re-energized on the other side, and so that shows you how ball lightning can go through glass. But also ball lightning, if it's excited too much, it can actually eat through the glass, and I think that's probably due to the difference in glass. And I will share this now. It's something I've never really discussed before. I discussed it with Andrew Johnson probably about 2.5 years ago. But essentially, if you're in a high-rise building, they tend to replace normal glass, soda glass, sodium-based glass. They harden it, and the way they harden it is they replace the sodium ions in the glass with potassium, and potassium has potassium-40 in it. And so when a ball lightning approaches normal glass, it doesn't get overly excited, and the core of the ball lightning will travel through the glass and maybe get excited on the other side. This is what might happen in many examples where that occurs. But in the case of a high-rise building, which would necessarily have hardened glass, where the sodium ions on the outside are replaced with potassium ions, of which a proportion of them, I think it's 0.12% or 0.012%, will be potassium-40, the second shortest lived of the primordial isotopes. The relic neutrino condensate, or the neutrinos in the form of the itons in the clusters, will interact with the potassium, excite them by releasing high energy beta particles, 1.55 something like that mega electron volts, 551 or something, and that will excite the plasmoid and it will burn a hole through the glass. Similarly, there is a proportion of potassium in concrete, and so the same process would be why you see many images of ball lightning boring holes through concrete bearing material. And I believe the exact same thing occurred when the ball lightning that was created by Pons and Fleischmann in the mid-1980s went through and the lab table and went into the concrete and took out a large chunk of concrete in the floor of the lab where they were. And there you go. Now you understand that. All right. Okay, so these things can persist. They persisted in the singularity of Pons and Fleischmann. They've self-sustained in other experiments, but this is showing you specifically how it does it, the shape of the structure. And by the way, this is 50 micron, right? So I would suggest that this is 30 to 40 micron. This is the same size as this. This here is the same size of exotic vacuum object, itonic cluster, ecton, whatever you like to call it, ball lightning, let's call it ball lightning, that's boring in here as is doing here. In this case, it's producing a light, okay? This is an observable light. I believe this is because electrons are coming out at high energy and or photons, and they are ionizing the air around it, producing this glow. That means then I think it's because it's either interacting or converting the matter. And I believe that would account. You've got two processes potentially accounting for the electrons that lit the bulb. One is the electrons that were first condensed into it, and the second is the coherent matter transmuting matter into light and leptons, and that is what's occurring in this. So there we go. I'll have a look at your questions now, and then I'll do a recap, and then I'll call it a day. But I think now we know how the Hutchison effect works. We know anyone now that has been able to follow this data this far and still believes that some other process is going on in LENR. I don't know. Maybe it is. Maybe everything that I've shown you for the last 5 years is wrong. But I doubt it, because it's so hard to fail, because every time you look and bother to look at samples, they show the same pattern of evidence. It doesn't matter what system you're looking at. Of course, if you do not look at your exploded tungsten, or you don't look at your exploded tungsten electrode, or your exploded or disappeared molybdenum structure, if you don't look at it, you can pretend something else did it, like heat. But it's not thermal, a lot of this. It's not thermal. It's not thermal. What I showed you on that copper proves this is not a thermal process. It is a coherent matter process. It is not thermal. Can we do that and put that to one side? Okay, so I'm gonna yeah, I mean, all you have to do is to be above the age of 5, be able to use your 2 hands to pour water from one vessel into another, and know what aluminium foil is, and have a budget of about $5 in the round, because you buy the $35 ultrasonic device and you sell it for $30 a couple of days later, and you have all of your samples and you can go and have a look. And I believe that if you spend the 90 seconds that I did, you will see these coherent matter tracks, and they will look exactly like I've just showed you in this presentation, and those will be interacting with light in a way where a polarizing filter will view it in a different way to a non-polarizing light, a polarized light. And so, you know, maybe people aren't of the age of 5, and maybe people don't want to spend a few minutes, and maybe people don't have the budget of one decent meal. I don't know. But you have to really want to not know that this is true now. You have to get to a point where I don't believe ball lightning exists, despite all the evidence on all of the hundreds of years of testimonies. I don't believe that alchemy is possible, because why would people do it for 5,000 years and probably a lot longer? You know, I don't believe John Hutchison did anything, despite the fact that everything he did is on camera at a time when you couldn't fake it with technology. There was no CG around then, and what he did is all logically consistent with what you observe on the samples afterwards, and the technology is all of the same thing. It's all the same thing. Okay, Bob, did you see my question about samples? No. Have you got some samples to send me? Great. If you can send them to me, if I can get to, it costs about $500 per day to use the SEM. It is the best situation I've had on this side of the pond to be able to. I would obviously like to be using Alan's SEM. Unfortunately, there's this fascist rule in place, and I won't talk about this at the moment, but I can't travel to the States. And so the thing is, Alan's device can only test things up to a few centimeters because of the size of the chamber. This has a 10 by 10 by 6 centimeter chamber. So I was very delighted this week to be able to fit the Lion 1 sample in there, because I've been wanting to look at it for a long time, but there's just no way I could look at it. Either people wouldn't allow me to put it into their device, or it didn't have a big enough chamber if they would allow me to put it into the device, and I didn't want to break it, because I know quite a lot about this sample and where things are on it, and you know, after 4 years to find what you see on the screen and it to have a one-to-one correlation with what the Moscow Nuclear Physics Institute is doing, and they have shown that these persist for days after, and this definitely had happened after the cooling of the reactor. This is 100% certain in my view. More than almost any data before, and it's a lovely bookending to the Lion story. And I know that when I go on the SEM, this is going to be spectacular when I can look at this with SED, having known that it was there, and go in and look at it. And I may even be able to get some 3D geometry from it, so that we will understand some beautiful detail about how this coherent matter is destroying the matter that it's moving through. Okay. So, Bob, what do you think is the most fundamental application device could we produce that could get us up and running, toying with this matter? I think that for me, and I this is where I'm interested in. It's dealing with radioactive waste, because if you can literally see on screen that this over here is a real thing. This is published in a peer-reviewed paper. This is not published in a peer-reviewed paper. I'm not at some fancy institute, and neither is the Lion author, but this is real. This is self-evident. You do not have to know anything to know that this happened in the way it did, right? Something that looked like this bored into something that looked like this, which is completely homogeneous. And if the trail and the edge around this has different elements, they were synthesized in the process. 100%. 100%. No debate. You don't need a peer. This is its own peer. This is nature saying, listen, this is what I'm doing. Pay attention. Damn you. So I want to fix the radiation remediation. I'm very happy now that we're in a position where we understand the technology enough that I've actually set up the supernova reactor for the first time in about 3 years in a position, because I'm going to get the materials to produce the shielding, and I'm confident to use it. I don't want to leave my children fatherless. The person that built the reactor died at 40 from breast cancer, and he must have had a lot of flux of strange radiation. When you're seeing things of 40 microns carrying trillions of atoms that could go into your body and blow up with energies that are going to damage red blood cells, kill red blood cells, and cause cancer to white blood cells, you don't want that in your body. You do not. And by the way, anyone working near fast spinning things, cavitators, electric arcs, will be exposing themselves all of the time to this. This has profound implications, and there is an entire industry and requirement for legislation for protective measures for all of these workers. And I believe that when those things are in place, the cancer rates across the world will plummet, because we now understand a type of radiation that no one had a clue about, and we can physically see it. You can physically see it. It's not something that you need to debate anymore. You know why it produces the strange radiation tracks. You know how to see the strange radiation tracks. You know how it's interacting with the matter in order to create those strange radiation tracks and the light play on those. You know that it can destroy matter and convert it into other matter. Okay? Can you pipe in longitudinal sound to perhaps Schumann resonance along with ultrasonic? You know what? I would create a series of tubes that are parallel, like a cloudbuster, because you have resonant modes that are linear, and you can create coherent sound like that. And that's how. By the way, that's how the cloudbusters work. They produce a coherent sound beam. A coherent matter, actually. They produce a coherent matter wave, and that causes the clouds to form and the rain to happen. Now you know how that occurs. You can go and look at Frolov, and he discusses that, but he doesn't discuss the mechanism. He discusses the fact that it's producing coherent matter waves, and that's exactly what it's doing. So we can manipulate the weather using that with simple devices. But now you can understand that there is a true mechanism behind it. So manipulating the weather, you know, if you want water for your crops, you can remediate waste, produce electricity and light out of ordinary matter. You can condense any form of matter, so you can make energy at any point in the universe. You can travel. You can shield yourself from inertia and mass, the effect of the push force of gravity. You can produce both propulsion and allow the push force, the thing that causes the action of gravity, to push you in a direction by removing shielding selectively. How do you make electricity directly with it? Well, you feed it matter, and it's described in Ken Shoulder's patterns, but now you can understand kind of how it does it. As it's cohering matter, it sends out photons, and then you have a photoelectric material. I would use yttrium on copper or copper oxide. Copper oxide is the one that we use because it's cheap in the Vega experiments. So when the photons hit it, the copper oxide then emits electrons through the photoelectric effect, and so you get a net gain in electricity. This Soliton patent from 2001, he creates the coherent matter structure, which has a high rate of rotation and of matter around it, although the structure itself may not be rotating. And then he has a single induction coil, and we are working on that. David Boutillier is working on that in Canada, and so that's one way of creating it by induction. Yes, I have looked at it with ancient Egypt. I'm going to talk about probably later in the year. I visited some archaeological sites in Northern Europe during last summer. Something that I've been following for a long time. It's never discussed anywhere, but I think they knew exactly how this technology works, and I took some very high quality video and footage of that, and I will discuss that at a later time. I really wanted to make it absolutely 100% certain that this is what's going on before I spend a lot more time on the historical knowledge of this. You don't need a lot of yttrium. I mean, yttrium's so good at the photoelectric effect, you can use even visible light to get it to shoot off electrons. So, you know, this is producing visible light. It will cause some electrons to be released from yttrium. So Ken Shoulders had a traveling wave tube with a half bias, your negative bias at 1 and your ground, and he did a pulse. The EVO came down the channel. It radiated these photons. The photons, 2 kiloelectron volt, interacted with the photoelectric material that emitted more electrons that travelled along with the EVO towards the positive thing, and you get a net gain in electricity. Bob, if they can explode in the body, then they can heal the body. Okay, so when Shishkin and his team from 2019 studied the biological effects, they found that if they took rats and they exposed them to, say, exploding foils or whatever before, a flux of strange radiation stimulated the production of white blood cells, such that if they post-exposed them to a cancer-causing a dose of gamma rays, that then they were less likely to get cancer after an exposure. But the reason was that their white blood cells were stimulated to produce more by the influx of the strange radiation. In the case of rats that were exposed to gamma rays to induce cancers prior to exposure to strange radiation, then the cells that were then cancerous were accelerated in growth by a certain quanta, I guess, of the strange radiation, and this meant that the cancers were accelerated. And this is the same story that David Hudson says for Ormus. It can't cure cancer unless you don't have cancer. It can then help prevent it. But if you've already got cancer, it will promote. What this does is life likes to use this stuff if it can get it without directly damaging it. And so a cancer cell wants to grow. So it will grow, and one of the areas in your body where there's a lot of new growth happening is in your bone marrow, where it produces white blood cells, so it stimulates that growth. I think the right approach is the kind of approach where you use corona discharge onto water, or you agitate water ultrasonically. Not too much, because you don't want to be creating lead. You don't want to be, this isn't a case where you take it to the max, because if you take it to the max, you will produce things that will poison you. Either the radiation, the elements that will fission and produce normal radiation that will kill you, or so on. But if you do a little bit of ultrasonic vibration to water, or you expose it to natural flux of this from the cosmos with say the south pole of a magnet underneath at say 0.4 Tesla, that will collect it into the and it will bind to the oxygen dissolved in the water. Or you can use a cavitator for a short run. And in the case of Shishkin, he applied that to plants, and they grew faster and were more resistant to disease. Another Russian group was working with a German group, and they used corona discharge onto water, and then the water was applied to plants. Same thing, germinates faster, higher weight of plant mass, and more resistant to disease. And you get these kind of things occurring in areas, for instance, where I lived in Kerala, like literally everything grew quickly. And there's a lot of lightning in Kerala. So nature is designed to use charge clusters, but charge clusters, at a certain level will be very damaging. So it's about balance. It's about not using the great power of it. It's about working with nature. Yeah, use an air stone. I mean, the Ayurvedics used to use like a type of graphite or something, and they used to pump air through that, and that produced very small amounts of nanobubbles, and so they would adiabatically compress to produce oxygen-rich water. So I think some of the Ayurvedic processes, whether they knew that, whether the people now know why it does certain things, I don't know. But I think someone kind of worked out, if I do A, B, and C, it could have come from deep knowledge and understanding. And I suspect since the temple line from on which the food dog is based in the Forbidden City in Beijing, since that is the structure, in my view, of ball lightning, or the coherent matter structure on the inside, I think that at some point this knowledge was prevalent across the whole world. Well, that's great, WP for truth. I don't know whether I would like to see these bagels potentially used to see, like, if I have a bagel and I grow a plant inside the bagel, and it's either charged or it's pulsed on maybe Cosmic Dave is he's suggesting that it's producing a field that lasts for something like 1 hour. So if you just energized it every hour, and then you took another plant, taken from the same batch, and you treat them exactly the same, and this is where it gets a bit complicated. But we know lunar cycles change the amount of potassium synthesized, or potassium calcium ratio, from an Indian study in 2013, and so gravitational lensing works. Can these bagels improve germination and seed growth? Okay, I'm just going to try and quickly go through and see if I can catch any questions, and then I'll just do a quick recap. Is there a special way you want them sent or prepared? This is WP for Truth looking at samples. To be honest, I look at samples for things that can't be contamination. So what you're seeing on screen can't be contamination. Yeah. So I'm looking for, because if you say, oh, I'm seeing an element produced, and it's like, well, okay, but could it be contamination? Or I saw energy produced. Yeah, but you didn't do your Stefan Boltzmann right, or you didn't have the thermometer in the right place, or you didn't have enough thermometers, or whatever. I've been through all these arguments, and you're just you're beating your head against the wall. This is self-evident. This is not open for debate. This is a structure that's self-sustained, and after the cupric oxide had cooled and produced this glassy substance, this burrowed through it. And I think when I get another chance under the SEM, which, as I say, it costs $500 a day, excluding my time and costs of food and whatever, transport and that. So thanks to all those people that support it, because this is only possible because people out there supported this. That this is supported by the highest levels of Russian science, and I think that what Lion achieved in this experimental series, I said at the time, not that this will be one of the most important experiments of all time. I said this will be one of the most important experiments. I didn't give a date on it because I think I already knew from the initial strange radiation track I saw in September 2017 that it was unbelievably important what had been achieved in this experiment. But to see this, it's a seminal moment. It's a completely transformational moment, and it'll take a long time before people understand how self-evident and what this is telling us. And I think getting a higher fidelity on this particular structure is going to give a lot of scientists food for thought moving forward. So in terms of preparation, just try not to contaminate it with things like paper. Paper has calcium all over it and so on. And so I would suggest put it in a polyethylene bag, one of these Ziploc bags, and then put that Ziploc bag in another Ziploc bag, and then put it in bubble wrap. And that way it doesn't get physically damaged, because I'm looking for structural things, and it doesn't get, how should we put this, contamination from paper, because paper can have all kinds of stuff on it. I just want to know how to do propulsion with it. Well, I've described several methods, several that are described by Ken Shoulders, and you can go and look at his work. And I've described one that I believe is the mechanism behind the tic-tac and spherical craft. And the tic-tac and spherical craft are the best technology that will ever exist. There's no other option beyond that, because the nature is optimal around a sphere or a surface of minimum curvature. Maybe a torus as well, but the torus has its own problems, like stuff goes through the center of the torus. So if you can see that nature is shelling something, as it does with the torus and the spheres that I've shown you here, and you understand why that is, and we'll go over that in a second, then it's just what happens inside that, where if you are shielded from the Akashic record, if you are shielded from the conscious connection to other people, you will need a source of relic neutrinos in there, which is lucky that we know how to do that. That will stop people going completely mad. But you will lose a sense of reality when you're traveling in these devices. And that's why you might choose to have devices, if you're using them on Earth, where the devices are reducing the mass of the overall object, but the area where the person is still able to see a flux of relic neutrinos. So, these devices that use the torus structures in the ether are probably more suited to conscious travel. Well, other than that, you might have conscious control of the device, so there's that. Yes, join the techniques. I'm doing it anyway. Well, dilution is the solution to pollution, so keep your distance from it. Yeah. Do we need devices that, so this is from 3, do we need the devices of smartphones to start playing with meta? Surely if the tools... there's certainly devices you can use on a smartphone, and I've used these devices for many years. I've used the sound capture, where you can have a fairly cheap software to do spectral analysis of sound. This was very important to do sound analysis when I was looking at the Dr. Marza vibrator plates, because he thought he was running them at 169 hertz or 100 whatever hertz, in the hundreds of hertz, but yet they were producing ultrasonics. And so that got me excited, thinking that this was actually doing cavitation, and it was doing cavitation. I've shown that recently, so we know that it's doing cavitation and consumption of matter, or at least damaging. And it would appear that you have these flux loops and so on going on there, and it produces strange radiation, as I've showed you today. Here's an odd question: carbonated beverages, do bubbles leave any ethers? I don't think so. No, I don't think there's a sufficient energy concentration. I don't see how that would work. So make all the matter you need with taking all the matter you don't need. Yeah, I what I'm saying is, and I've said this for many years, is that at some point you will be able to use this technology to convert toenail clippings and dog poo and hair and waste food into energy and other matter that are more useful. And that's it, because and it will do it incredibly efficiently. When you understand when you get to the point of understanding the resonance, it will like to make a lot of iron. If you push it too hard, it will make a lot of lead. It'll obviously make a lot of carbon, silicon, calcium and stuff. But a lot of the things it likes to make out of whatever you give it tend to be the things that life needs. And that is why I think this is the flower of life. So just for people who want to know, I'm just looking at your comments. So here's the thing. The people that are watching this video have a huge advantage if they are fairly competent in English. I implore everyone to be open with their research. I know that greed gets the better of some people. I know that they like to pretend that they invented something. You cannot invent this. Humans already had this. It is not your right to take this. It is your right to work as a community to make sure the world is a better place. And if you have the skills, I believe it's incumbent upon you. It's your duty to give rebirth to this technology that humans used, probably as a genetic material, to get to this planet and spawn the human race. You know, there are some brilliantly technical people out there, but you cannot own this, and the system will never allow you to own this. This is why so many inventors have failed. They got inventor's disease. They tried to patent things. I know personally 3 different patents that in the field of Lena, where the patent holder was told, sorry, you can't ever talk about this again. And so and other people in other fields where they've developed something, they could never explore it. And in fact, when I was on the Thames on a yacht with my brother's nano drone technology, which he has a worldwide patent for, talking, there were some military people in the room, and they said, look, you know, if you do apply to the patent office, likely they'll just turn around and say, well, sorry, you can't use this, but we're going to, goodbye. And that would be it. So I shouldn't bother. The important thing is now we are verging on being able to use this technology again. There will always be idiots that want to dial things up to 11. This is not one of those situations where you dial it up to 11. No, you don't. You don't. Because you will be one of those people like Yuri Bajatov or like even Ken Shoulders. He died riddled with cancer, and it's quite likely because he did not have the shielding that we've been talking about. And that's why I've spent so many years focusing on the protection and finding the way to protect people that might want to do this research before really making it extremely clear how it works. And so, you know, anyone needs to go and look at every article that I've shared about protection, because even when you're trying to do things gently, occasionally, you know, like Leclerc, just 1 hour and they nearly killed themselves with a cavitator. And the fastest way to produce a lot of this, like I say, the biggest crenellated sphere that we produced was within less than 1,000 seconds in a domestic ultrasonic cleaner with aluminium foil. Right, less than 1,000 seconds. So you've got to be careful. You've got to be careful.
Okay, so Duke Treat 64 is saying, so the point is that strange radiation marks polarized light because coherent matter tends to prefer 1 micrometer size, and the size happens to interact with visible light wavelengths. Okay, kind of. That one of the quantizations of this is that around that 1 micrometer, and this is actually talked about by Ken Shoulders, so you can go and look at his references to that. But it has quantizations above that. Obviously, we've seen on the Hutchison sample 1.6 millimeters for that big one that I derived the N-level Tor structure from, and so but you can imagine that, because it's fractal, it will always have a component that's at that one micrometer scale, and so it tends to leave this thing that is able to be seen by polarizing filters. It's able to separate it out. So yeah, that's essentially it. When it worked, like I say, I went into this thinking I've used polarization in my 3D animation. I've used it in my videography and photography to separate out details. Let's get the polarizing filter on the microscope, because I think that will give me more chance, if there's anything there to see it, because it's able to separate out things that light plays with in a different way. It's only with what I did a few weeks ago with the ultra experiment, and I saw those lines, regardless of the actual milling lines, the rolling lines on the aluminium foil, irrespective, they were producing these incredibly specific tracks that were obviously produced by coherent matter moving through it because of the vortex nature on one, and the completely on and off nature of the interaction with the material. It showed this event horizon that we'd seen in so many different systems. So it definitely was that, and then to see this with the with that impact of the soliton in Henk Uren's copper tube with the same scale structures, and then to know that we had these vertical regular array of structures in the solitons that I videoed in 2017 in Suhas Ralkar's lab in Mumbai. The combination of those things, it's just painting a scenario when just nature is doing the same thing every time. So this is, in my view, a good way of detecting this type of radiation. So Axel actually is saying the EVO produces a special type of magnetic field which produces transmutation. The field is unlike ordinary magnetism. I don't know whether it's special. It may be special, but I tell you what it is. It's very, 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 very strong. And what seems to be what's special about it is it's highly focused. It doesn't like fall off in a linear way. It has this kind of event horizon. So it's kind of like closed loop. And so is it this closed loop pointing vector, this magnetic, this flux energy that's going on? Maybe. So that and many of the faces it's being reflected off are oriented in the same direction. Yes, okay. So that's what it kind of is. Yeah. So that's why I was saying the spiral, but also the fact that it's round and the rest of the surface is producing diffuse light. So if you've got something that's able to interact with the light differently, so you've got diffraction and actually playing with the light differently. So it's a combination of things. It's one thing I was trying to wrap my head around when I was looking at some of those strange radiation tracks on the Dr. Roshan Amar's vibrator plates. Why am I seeing these things? I'm actually seeing some of the form, not just the fact that it's separated from the background by the polarizing light. So yes, that's correct, Gordon. I did think initially that the reflected light was being reoriented by a magnetic field. I do believe some of that's going on, and I've argued that with the flood area of the Vega Valley, where you see those red and green sections that are of a very specific size. And when you look at that under the SEM and the microscope, you do not see this type of how do you say it, physical damage that would do the play on light. And it's specifically doing this red and green and red and green. And that is when the torus is directly flat on the surface and it's rotating it that way, and the other one is next to it and is rotating it the other way. So but you can't physically see the damage. So in that instance, I'm saying that it's done something to the spins or left a residual magnetic component. That might be the same on metals. It might be changing the spin of the electrons in different ways as it's traveling through. But from a purely easy to understand way where you can physically see, we have at least, you could argue, a 500 line or potentially a 1,000 line diffraction grating. And this is very, very easy concept for people to understanding why polarizing light is able to enhance the visual presence of strange radiation tracks. Yes, coherent fields produce polarized tracks. Harry, so we can use cavitation to create any element. Yes, we can. Yes, we can. You push it too far, you tend to produce a lot of lead. It's better if you start with aluminium, because aluminium is one isotope. It's cheap. It's the third most abundant element in the crust after silicon and oxygen. The problem is you push it too far, you get transuranics, and you start to kill yourself and contaminate the water. You have hot water. So WP for Truth says sound, light, and vibration, all the same thing. Okay, I'm going to look down the bottom, then I'm just going to do a quick recap. Bob, do you think that this is the apple from the Garden of Eden? It's certainly the occult knowledge, but it's like it's been so hidden in plain sight. It's almost like whoever was carving most of the significant symbols of power and putting these symbols together in groups. Genuinely, people forget stuff. Even people forget stuff within their own lives, even within the day that they're living. So it is quite conceivable that a cataclysm happened, even potentially from overuse and misuse of this technology. Because I argue that if you use too much of this technology, you go to the max, like you had a battle with some of this technology, you could end up messing with the Earth's magnetic field, and that holds the crust in place. So you would end up with it rotating around on the core. So this has to be used respectfully. And, you know, there are just idiots everywhere. There's just idiots everywhere that always think that they want to dial it up to 11 because more is better, right? More is better. No. Yeah, the Maunder minimum is a real issue. It means that we're going to have a minimum temperature about 2035, 2034, 2036, around that region. And so they have to push a big narrative now to get the money in their pockets for the global climate change scam. And right now you've got people who are in the position to control your lives, deciding on, and I have to admit, when I was fully bought into this scam and I was developing technology, I was thinking about producing well-meaning technology so that people could monitor their own carbon use. But now I see that they would want it to control what you can do in your life. But the reality is, with this technology, there is total abundance of energy, of being able to produce vast amounts of the right kind of minerals to enhance plant growth, to minimize the use of real fossil fuels like coal, or potentially slowly renewable Lena-produced fuels like oil and gas. We are in the position, in this little group, of potentially completely understanding how to create a world of total abundance. Okay? And it's a special place to be. It's a place that I'm sure there were humans living at some point, and there are also certainly billions of species throughout the universe which are in this position already, of not worrying about destroying their environment. But you get these stories. The other thing is like you have all these pristine wildernesses because it's impractical for people to live there. This technology will make it practical for people to live literally anywhere. Literally anywhere. And, people are, a lot of people don't clean up after themselves. So, they will make a mess. And so you end up with places that are not pristine anymore. But you kind of, this technology can solve, making potable water. It can solve dealing with waste and converting it into useful stuff. It can deal with all of that. You are literally right down. You're at the root level of the universe. You are the boot level of control. So Steve Whetstone is saying there's going to be a problem around 2048. I think it's my premonition is around about 2033 to 2036. But I think that if we learn how to use this technology responsibly, we can mitigate the biggest problems. Yeah, I agree, Steve. I've been specifically told that there are people that don't want this technology out. Although like I say, the easiest thing you can do with this technology is destroy stuff, and you can literally see it self-evidently on the screen there. This disrupts matter, and this is. It's just 100% disrupts matter. There's nothing you can do about it. I mean, what you saw on that copper tube, which I'm going to look at in a sec with a review, is 100% destruction of the copper within the field sphere of influence of the coherent matter. This is lightsaber technology. You coat this on the outside of your saber and your flaming sword from antiquity, and it will cut through any other metal like instantaneously, and it will likely convert it to gas or light and leptons. I like Bestoic Primer's idea. Make two toys, release a year apart. When they combine in some way by accident, it generates free power. Very nice. I like it. This technology protects itself because it's just too unbelievable. I've said that many, many times, but it's totally true. You know, you could show 999 people out of 1,000 this image, and they wouldn't have a clue what you were talking about. They would not have a clue. Until they died, they just would not have a clue. But serious researchers like these Bogdanovich at the Moscow Nuclear Physics Institute, national research in Russia, they know exactly what it is. I'm pretty certain they know a lot more than this paper lets on. But you know, my view is, and I've said it before, if they don't show it, they didn't do it, right? And this is from the Lion reactor, and there it is. It's doing it. Yeah, Kathy, I do believe they are, but did anyone see that sham thing about UFOs in the US Congress? It was so appalling. It was so appalling. Like, I don't know, what, 50 years or 40 years? I don't know, since they had last hearing. And it was basically a complete nothing burger. And you either the people that get paid hundreds of billions to investigate this stuff or to be expert in this field are complete idiots or they are deliberately covering it up. They are. Maybe they are genuinely stupid people. They are genuinely thick. And all of the money in the world is just trying to find out all the ways that this doesn't work even better. Doesn't work. But it is real. Nature does this. Sorry. and that is evident with what you see in the Hutchison videos of his effect. Because I know, having done 3D from the beginning of 3D, that what I saw when I was working in 3D in the 1990s, what he had produced in the late 1970s and early 1980s is very difficult to fake. It's very difficult to fake. So it wasn't fake. So then you've got to say, well, this is prima facie, it's real evidence. What is it trying to tell you? How did this happen? FBV Angel, they were working on this in the 1800s. I believe Tesla was referring to ancient documents. I believe that a lot of his understanding, like Leonardo da Vinci, was just paying attention to what people were saying they were doing in the past. And going, well, if I did what they're telling me I'm doing, what would happen? Oh, this would happen. Great. You know, For me, you can get yourself into a self-consistent mathematical wormhole where it sucks in all of creativity and everything down into this mathematical vortex, which just consumes and consumes intellectual capacity. But this is the kind of vortex I'm interested in. It doesn't need anyone's opinion. You just need to look at it and ask yourself, what is it doing? What is it doing in this frozen Cu2O, this completely glassy? What is this thing doing as it comes through here with these kind of curved sections on here? And this is just at this level of fidelity. When I get another shot of this, it's just going to be mind-bogglingly clear what happened. Yeah, Sumerians knew this science, absolutely, 100%. Or the people that are talked about in the Sumerian tablets knew about this. Bob, would a spark gap collapse a bagel generated self? Yes, it should do. Yes. And in fact, I would suggest people have spark gaps around. Basically, it's organizing a torsional field, but it's interwoven, and you need it. You need to get rid of it with a good old whack of a discharge. Kathleen, they don't need to. They can learn the basics of this from 5-year-old. I can do this with my daughter when she was 5. With the ultra experiment, and it produced the same result every single time. The Lion reactor produced the same result every single time. I suggested using commercially available diamond nickel or diamond boron nitride abrasives in January of 2013, and I specifically made a point of saying, look, I'm putting this out there for people to explore. I don't want anyone to have a patent on it. And the Lion author was the first person to try diapads, which are nickel pads with synthetic diamonds in them, diamond abrasives, in 2017. And every single experiment he did produced the same quantum coherent nuclear reaction signatures that I was to later find out Solin had in his patent in 1992, his awarded patent, Russian patent. And so it's replicatable. There were some things that were not clear about the parameters when some people tried to replicate it, but you always have this difficulty in believing something is possible. It's possible, and that's what's happening here. And if this matter was removed, I'm pretty certain that some of it will be converted to light and leptons, which would account for the electricity. FPG Angel, are you getting any kickback from the science community, Bob? The beauty of putting a few wackadoodle things in there and a little bit of crazy is that they dismiss you, and then it's too late. And I think it's too late. It actually doesn't matter what happens to me now. It really doesn't. The facts are there. They're self-evident. This is self-evident. And it matches all of the archaeological record. It matches what was said was able to be done in most of the world's greatest religious texts, and the way that occurred. And when you match up how it was said things were done with the properties of the matter involved, like the fact that rock that you build buildings from is got a lot of quartz in it. So you can easily understand the walls of Jericho, the crossing of the sea, the fact that water is diamagnetic, it will move to the outside of this structure, so you will be able to cross the sea. And this would also explain what we observed in the fused quartz of the Lion reactors, the glassy-like substance on the crossing point. Everything is consistent with the nature of the materials that are immutable, and with the way this technology works. And so, those stories are real. Get over it. But what they were talking about was technology. They were using the gods' toolbox. They were using it. Were they gods? Or did they just appear to gods, appear as gods to people that witnessed these things that no mortal human could do? Maybe. Maybe not. But it is technology. I think my personal belief is everything is God, and the intention is God's will, and what you're seeing here with this exotic vacuum object, this cluster eating through this cupric oxide, this is God's will in a very small way. And it was God's will that the Lion reactor was sent to me, and it was God's will that I didn't get a chance to look at it until this week and find this structure on there. It's all God's will. It's all the intention. It is God's will that we are able to learn this now. And it's being done for a reason. In 2017, in March, around the second week in March, I said, this is Revelations, you're in it. And I firmly believed that. I firmly believed that. And I said that they would stop at nothing to prevent this technology from coming out. They will use the scorched earth policy. And we're going through it. We've been going through it. We've been going through it. But we will get through it. It will be got through. And you may well be, all of you, part of the solution. Part of the solution. If you want to, if you can will to do that. If you can invoke it, if you can manifest being part of the solution. Hopefully you understand that it is possible. And the thing that Hutchison gave me was a sense of these things being possible. That's why I call the book that I will write for and of him and of his samples is Mr. Possible. It's not that you need to know how it happened. You just need to know something is possible. If you never see a person jump a fence, you think, well, maybe the fence can't be jumped. But if you see someone jumping the fence, you go, you can jump the fence. Maybe I can jump the fence. That's the kind of like ethos behind the Olympics. You know, what is possible for man to do? What is man's greatest achievements? If you never see a plane in the sky, you don't know that a thing can fly in the sky. What you're seeing here is that something is able to persist after an experiment has ended for a period of time, and it's able to consume matter of its own volition. And is this a living organism? Is a living organism that wants to move in a direction of its choosing and consume matter? What is life? Is this life? Is this alive? Kathy, I've known since I was in my younger than 10 that I would do this in my 40s. And I couldn't have wanted the story to go any better. And so, as I say to my wife, thank you for putting up with this, because she has had to put up with a lot, the poverty, etc. But she understands, and as I say to her, I'd say to her all the time, I'm so proud of you for putting up with me, because I knew I had to do this. It wasn't really her burden. But I just think this is the most interesting thing I can possibly do in this universe, in this one life. And I feel just so deeply honoured. It's just about deep honour. And all of those people, like Dr. Roy Shinamaza, like Matsumoto, like Francesco Piantelli, like Alan Goldwater, the immense contributions he made, Matthew Villat, all the founders, Ryan Hunt, all the people that helped get this off the ground. The donors, I mean, like I say, Stephen and Charles made this analysis possible. And the willingness, principally, of claimants to allow me to visit and see their technology and see if there's any truth to their claims. That takes guts. It takes real guts to put your and you can see on video me having arguments trying to get around the ego of Dr. Roy Shinamaza. But we found a way to move forward. And I'm so thankful we did. We're so thankful. I would not be able to share with you today what I had to share with you if it wasn't for my experiences with Dr. Roy Shinamaza. Seeing that transmutation after the event with the snowballs on cobblestones, those the sulfur being synthesized from the oxygen and the copper from that system, and knowing that that had to happen over a period of time because you've got this thing getting bigger and bigger and making larger amount of sulfur. And Dr. George Eagley, his contributions, it's just so many people. It's like, I'm sorry if I forget people, but and the people that support me on my blog, it's just I just have to thank people. Okay, I'm going to do a review. It doesn't actually matter what they do to me. Doesn't. You know, I do want to go to the States this year. I hope the fascism ends. You have this bizarre thing in the world where, you know, the number of deaths in the world from the sniffles is now just a few tens or hundreds away from when the WHO declared a whatever it is of international concern. I think before it was like March the 11th, wasn't it? I don't even think it was classed as a pandemic, but if it was, we're basically back at that level. And so we're coming out of this, and yet you still have Australia and New Zealand and Canada and the US requiring people to have an experimental product in their body, which is known to not work now. I think you have to be literally brain dead to know that, still think that it does anything now, and has real harms. And I've heard of another couple of cases that are close to me in recent days. And I've already had the sniffles twice. I had the original version and the Omicron. And you know, it's just, the Omicron was a joke. I mean, it was like less than a pathetic cold. In fact, it was less symptoms than people are claiming for having a jab of one of the experimental products. So what is the point of taking something that is only likely to harm you? And why do I have to do that to be able to work in a normal way as a human being with the freedoms that humans should be allowed? And I think to myself, you know, am I shooting myself in my foot just for the sake of, no, I just don't want to leave my children fatherless. And so there we go. Right, I'm going to do a quick review. It's going to let me. Right. Ah. I think my machine has finally given up. I've pushed it to its limit. Okay. So this was O-Day mining sweeping, and this image, as I said at the beginning of the presentation, is one of the very many images that is a piece of artwork that encapsulates handed down knowledge from the desert tribes of Rajasthan, where I believe some of the most advanced levels of this technology in the previous epoch was used, and I thank them for recording this knowledge in their artwork that they hold most sacred when they bring a new life into the world, and have recorded on this tapestry. And I think this is a good representation of a coherent matter structure. It's linked to yin yang and the kind of the trails that come off with these kind of like things that carry along. So we discussed the structure of small clusters from the initial ones and clustering that I observed on the Lion reactor in late 2017, early 2018. The structure of the skin of large hollow spheres and toroids as per the ultra experiments and other claimants in the field, and the toroid impact that was observed on the copper pipe from Henk urine, and the hollow sphere inferred from the section of a sphere that was created by a less than 1,000 ultra experiment carried out by my dear colleague Alan Goldwater. And then the subject of entrainment of smaller clusters, which I shared with you how this works by looking at an ultrasonic system, which I videoed in the middle of 2017 in Suhas Ralkar's lab in Mumbai in India. And then the reason for strained radiation, and also in combination with the structures around the toroid in the Hank urine sample. Reason for strange radiation tracks being easier to detect with polarizing filter. The fact that when it interacts with matter, it does several things. I've talked about the magnetic shadow that it might leave in the material, the fact that it actually might be transmuting it to a degree, but this specific topic here was the fact that it at least it seems to produce 1 micron size features, which may actually be up to 1,000 lines when you consider there's a twisted pair there, and it's producing a round structure which will reflect light in a different way on its own, but also is producing a diffraction grating which is of the same type and scale that is used for diffraction gratings for studying light, and that would completely explain on its own the ability of a polarizing filter to observe strange radiation tracks more efficiently, and the self-evident proof of soliton self-sustained disruption of matter. And so we looked at some structures here, a 2-level, a 3-level, a 4-level and a 5-level on the Hutchison samples, on the Lion sample, and then from the Vega copper ball lightning cut we had what I believe is a 2-level structure with the yin yang, not the yin yang, well, it has got a yin and yang in there, but anyway, it doesn't matter. The vortex paisley, the symbol of the first of life and eternity for the first monoatheistic religion of Zoroastrianism from Iran. Then we have a 3-level one which also has this vortex structure, this paisley. Then we have a 4-level one, a 5-level one, a 6-level one, a couple of 6-level ones, and an 8-level one. And then I showed this vortex structure, and with Bogdanovich's work and the fact that John Hutchison was able to create it in steel in the ball bone sample with these kind of like buzzsaw type sections around the vortical structure that's chewed its way into this 1986 sample. And this is 40 microns, this is 4 centimeters. All of these systems are scale invariant, so they have the same structure as they grow, and this will go up to the size of galaxies. I am absolutely 100% certain of that. And this is in aluminium, so this is in steel, this is in aluminium, so different material but exactly the same, and it has these intense full 100% acting and not acting effects going on, and so we related that through to the structures, and then we talked about the skin of large hollow spheres and toroids. We spoke about Ken Shoulders talking about how it could skin materials, and the fact that we observed this on Hutchison samples and in the Lion reactor, and the fact that I published my thoughts on that in October the 4th, 2018 in the Seek and Share presentation to the Russian community in Sochi, and the fact that it's on the Temple of Osiris in Abydos as the flower of life. And the fact that they choose 2, I think that is very significant. I think maybe one is the maker and the other one is the breaker, but anyway, it doesn't really matter. That they have this coherent, intense layer around the outside. I think that's also important. That's reflected in this overall design. And this is in my view, the structure of ball lightning, which is, I believe, the flower of life because of the way it can reset matter. And the fact that we produced this in... Oh, sorry, what happened there? Don't know why that died. The fact that we produced this in Alan Goldwater's Magic Sound Lab using ultrasonics, and we produced it in a range of other technologies, but here we are, up to 40 something microns, and we found the split section, and we noted that these produce these triangular sections, and there's reasons for that which we discussed later, and that the inside of this can grow, but in this one it's like this is 100 microns, this is 10 microns, so this is like, I don't know, 5 or 4 microns, and it's got a wave function on it on the inside as well. Why is that the case? Well, I then went on to show with my 3D application, firstly, if I switch over to here, that we had our fractal torus, which is a tori of tori, n level, goes to any degree, in the microsphere, and here it is. And that we need to think of these things like this. And the fact that the fields pinch, we know this from Bostic and Nardi's work from 1980, and we know it from the Hutchison fracture sample that I derived this structure from in 2020, February the 17th, I think it was. And then we observe these pinching of fields. So we know that the fields can be pinched in these structures, and that 48 is the maximum that we've observed. I think it becomes unstable after that. That we can observe ones with much less, and that we have a simplified version here. And then if we go to this structure, we know that we can create any structure with a triangular mesh, and that they have pentagons, and around the pentagons you have a hexagon and a hexagon and a hexagon and a hexagon and a hexagon. Okay, so with pentagons and hexagons you can make any sort of surfaces. This is the same as carbon buckyballs and capped nanotubes and so on, that will be the structure of the coherent matter sheath in the Vega Valley. And that also you can make a toroid with this. And starting with this, we can actually build a structure. And if we start at the basic level, we have our torus here. And I'm going to go to just this. So we have our torus. And then what we noted was that on the cut area of the, where is it? I go here. Give me a second, just finding it. On the cut area of the Vega, ball lightning cut, which was around this area here. So this is where a large ball lightning cut a section out. This is copper pipe. This did not melt. This was not removed by melting. It was not removed by melting. This is not a thermal process. We saw on the surface you had this. In fact, the surface looked more like this. And then when you zoom into this area here, we're going to look at this area here. We went in and we can see that we have structures that are pointing up and pointing in the plane of the screen. So pointing across the screen and pointing in the plane, pointing in the plane through the screen. And this one maybe here has come around here and around there, and this one's coming out of here and working in a different plane. Okay, so that's that. And this was a bit closer in, and when we look closer in we get these wobbles, which may show that there's a magnetic field in there, but we won't go into that right now. And that here, when we start building this out, and bearing in mind this can have squashed fields in here, but I'm not bothering to do that. I will do this model with the squashed fields, and we keep building this out, and we keep building it out, and we keep building it out. We end up with a very tightly bound structure, and if we take any two loops, one could consider this as the interlocked self-sustaining four-tall bagel superstructure that self-sustains, and that is a loop within and a loop, and that the whole thing is made of that, and it produces the edge copper that we see in these samples here. And in fact I will go and straight show the torus. So this is our sphere with our textured wire. I'm just going to go to textured again, and I'm going to put that in the background. And so on our sphere we can have this kind of structure on there, and you can imagine that wrapped around the whole sphere, and that is essentially the flower of life that you see in this image here. Okay, or you would do if it would stay up. There, so that is what you see here. Okay, and that creates this. Minimize, make that smaller. That creates this edge here, which we showed was pure iron, where the vortex things that are coming out here are pairs or more of twisted, and as you move out, they're quite nice in the fact that they kind of, as they go out, they get, where is it? This one? Is it that one or this one? This one. Okay. Because the radius is increasing from here, this is the point of focus, but as it's going out, they twist out at where is it? They twist out tight, and then as it goes out, they spread out, and then the level of orbiting around each other gets a little bit more spread out, and a bit more spread out. But I argue that this torus came in at this angle with a load of fuzzy entrained structures orbiting and associated with it, but the ones, because it came in this angle, it stroked these out, and this left this around here. And I, if anyone needs any more explanation, here's the entrained structures that you would see in a hydrodynamic sense, and we have these pairs, vortex here, we have a vortex here, we have a vortex here, we have a vortex here, and so on, regularly arranged, a vortex here, and so on, around vortex, going into the overall toroidal structure here. Okay, so that is kind of that. And the combination of the two creates this coherent matter layer on here. And then, without going into everything again, we then talked about how those bands, those stroking bands that are produced here, how these, if they were dragged across the surface, or even these, which if you look at it, you have this raise, down, down, up, down, up. And so I would suggest that when you're looking at this, that the bit that's going down is, if I go back to the group here, not that one, there we go. What have I got here? I've got two layers there. I'm going to get rid of that. Okay, so I would suggest that the ups are these pieces and the down is this bit. So where you're seeing the up here, that is sort of this part, and the down is into the center there. The down is into the center, and I think probably the vortex might go into the centers or whatever. But anyway, we can do the minutiae at a later time. But it goes up and down and up and down and up and down around the outside, and you see that on the structure that was captured by Alan Goldwater also. Okay, so that is that. And then these structures, or just the coherent matter layer on the outside, I talked about the fact that these leave trails, and if I can find them, this one. Is it going to let me do it? No, I've clicked the wrong one. Sorry, we're going to get a pause here. Maybe I can move forward some other way. Okay, so I'm going to do it like this. So yeah, so we showed that how the strange radiation track picked out by polarizing light, polarizing light, polarizing light up here. Same type of strange radiation track as this coherent matter wave beam, and this is the coherent matter collapsed function. Okay, and then though we in fact also saw these beams coming out of these spheres in the edge of the echo fuel. So is it giving me my Photoshop back yet? No, it's not giving me my Photoshop back yet. Okay. Well, maybe I can show you the images in the directory without Photoshop. Ay, 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 ay. Oi, oi, oi. Okay, just stop it. Okay, all right. Nearly there. Window. We have our ultra distilled here, water test that I did for 90 seconds. And we have a toroidal structure coming in here. And it leaves these influence of the substructure, and that it is 100% on and 100% off, depending on whether the coherent matter interacted with the material. And you see, this is the boundary layer. It's 100%, and the material is pulled in and produced, made into a spiral, along with the structure that is moving through it. And there is one other shot which we had. It's 34, 37. No. It's gone slow on me. Anyway, you get the idea. Is he going to do it? Oh dear. Machines. I've really pushed the machine today. You've got to give it credit. It's done very well. A lot of very, very large images, videos, etc. So that was that. That was showing, and I said that was going to be allowing for polarized light. Because effectively it was the same amount of lines, or at least half the number of lines in a diffraction grating. And so that was that. And then the last thing that we went through was the self-evident proof of soliton self-sustained disruption of matter. And we showed that this pentagram shaped structure with these like buzzsaw cuts in this was equivalent to the ones that were observed in, if it's going to not flick out on me. Oh dear. Is my computer going to last to the end of the presentation? Maybe, maybe not. Oh no. All right. Something's going on now. I'm trying. Right, let's try again. So we had this structure here, and then we talked about the sword in the stone for the Hutchison effect, and the fact that it has this boundary around it, and around the boundary there were a couple of cutters here, and I believe that's how that fell in there. And then we showed, because we couldn't show it anywhere else, is it there? No, it's not. Where is it? Where's our line 3 image? Oh, somewhere. I've lost it now. Not my best review, is it? Okay, not my best review. Oh well. Oh, it's not there, is it? Give me a sec. Nearly there. Okay, there we go. That's our final shot. Okay, there we go. And I said that this was the same as Bogdanovich's work, where he has something the same size persisting for time, and that this cut into the glassy Cu2O. All right, there we go. So that's it. That is the presentation. So I'll just see if there's any last questions, and then we'll call it a night. FPV Angel, I was already at that conclusion in 2017 that they had already re-engineered what was already known to humans prior to the last ice age, most likely, and tried to cover up the fact that it was already known by doing certain things, mostly in the Middle East. I talked about this in 2017 at length, and I made it very clear that I had a choice to walk away from the science, knowing that this was already discovered, or rather rediscovered, or do my level best to produce what I realized would be an unimaginable amount of work in order to make it completely clear that this is possible and it's actually doing that. And so I would like to think that Azura is going to end, and the god of ball lightning will come to release humanity from the deceivers, as is in the Rig Veda. Yes, FPV Angel, I've talked at detail about the death ray, the 1930s work, and how it works. It is the same technology. Okay, so thank you very much. I'll leave you with a picture of what I believe is the coherent structure that is self-supporting, that is the flower of life, which is the same structure that is the core of the shell of hollow spheres and toroids at the highest level of this self-organization, and that this is scale invariant, and that this could be a model for the skin of a black hole or other celestial bodies potentially. So matter will be drawn towards it because it will consume relic neutrinos, and relic neutrinos are pushing all of the other matter, and when the other matter interacts with this, it gets converted into prima materia, which feeds the flower of life. And there is nothing that can resist it unless you're inside it, in which you're inside it, you are in a world of total quiet inside this sphere. And I will probably go to the trouble of modeling a full sphere with the pinched zones on it, and maybe I'll do a torus as well, and maybe a capped tube, so people can visualize what the most advanced technologies can do in terms of shielding from the effect of gravity and then using it in that respect. So I'm going to go to the background here and just make that in the background. So yeah, so when you're inside this sphere, if we go inside this sphere here, and we are looking out at our torus structure there, okay, we will have a sense of total quiet in that area, and that's it basically. So why are relic neutrinos attracted to evos? Because the evos consume them, and therefore they basically have a hole, and there's a pressure of this coherent condensate, and so they push into where the hole is. And so that's it. And if you're caught in between, you get pushed along with it. And if you get pushed along with it, you end up get the bigger the sink of relic neutrinos, the bigger the so-called gravitational well. And so you get pushed towards this thing, and when you hit it, you get disassembled. Brad Carthauser, your wife says dinner is in the fridge, you're 4 hours late. No, I tell you what, my wife cooked me an extremely lovely Vietnamese fried liver with onions, with chili. It was perfect. And roasted crispy pork belly with rice and boiled beans and carrots. And it was very, very delicious. So thank you, Kim, my beloved wife. Elias is saying which ethnicity discovered this. I think the technology was known in southern Africa probably about maybe 240,000 to 400,000 years ago. Whether it was being used by humanoids as we know them now, I don't know, but maybe. Bob put my plate in the teleport, yeah. Need more bagels for spacecraft skin. No, Cosmic Dave, you don't use the bagels to make the skin. The bagels, nature is self-organizing this that you see here without any bagels involved. You just need to create the basic evos and give them a conducive environment to self-organize. And Ken Shoulders is right. They are electronic structures that organize at electronic speeds. They will cluster together at fantastic, unimaginable speeds. So you need to create an environment where they're created in abundance and they are kept close to a device and so on. So you do that with you have an electron emission, field emission, and sound in order to keep standing waves, and they will aggregate in those locations and cluster, and you then keep energizing it until the clusters are able to be big enough so that they join into each other and they become one coherent, superconducting, super fluid condensate that surrounds the thing, and that's essentially what you're seeing on that Hutchison sample and the Lion sample in both cases. The bagel is really a way of exploring, in my view, the kind of like process, but at a very, very weak level. Very weak level. But it could have uses for, say, healing. It could have uses for the opposite of healing. But I would tend to try and explore those kind of aspects with plant life first. I wouldn't try and get too near it. It's there's a guy that talks about the mines. This is Elias, I think, in South Africa, and the fact that they might be this age. I also had the pleasure of visiting Great Zimbabwe in Zimbabwe, which is a weird structure, and it has weird stone effects on it, and it predates so-called all civilization there. But apparently it was, I think it was Enlil's home, and Enki was in northern Iraq, and they were brothers or something. And I think one ran the mining operations down in South Africa, and Enki was doing stuff up in Arabia. But it almost doesn't matter. It doesn't matter, because if people are observant enough to look at nature, see what it's doing for long enough, it doesn't matter where they are at any point in the universe, ultimately they will always discover this technology. They will always discover it. So we are so distracted in our modern world that we are less likely to discover it than people in the ancient world that didn't have those distractions. So they could have independently discovered it, but once you do discover it and you can engineer the vacuum, you have the possibility to go to other planets, and the energy isn't an issue because you can get the energy at any point in the universe. Inertia and mass aren't an issue, so you don't have the problems with relativity that you would otherwise have, and you can do things that in theory, inside this bubble that you see here, if relic neutrino flux is the thing that causes time, then inside the bubble, time stops. And I've talked about how the fact that you can go into the future by going into a bubble, the world goes on with its normal timeline around, and when you come out of this bubble, you're not a day older, but the world might be thousands and thousands of years older. So from you might be able to travel to the other side of the universe, and you haven't aged a second. In your own brain, you don't even perceive a second of time going. But when you get to the other end of the universe, the people that you left don't exist. Not because of relativity per se, just because of the fact that you didn't get exposed to time, but they did. Conversely, this is how you could appear to have a life of, say, 36,000 years, or however many years the Sumerian gods were supposed to have, because you could go to sleep inside this bubble for, I don't know, 6 months, and just appear every 6 months. And you only appear for 2 hours, so you could easily live for many tens of thousands of years, according to the mere mortals. But actually, when you go to sleep, you don't really perceive passage of time, do you? You go to sleep, something happens, and then you wake up again. Well, it's a bit like that, except for you can come out of your bubble, say, I want you to build a pyramid, and here's the tools and the mechanisms that you need to use to do it. I'll see you in 5,000 years' time. And then you go in here, 5,000 years' time, you come out, and for you, it's the same second that you went in. But when you come out, you'll look, oh, you've done a pretty good job with that pyramid there. And people go, you came back exactly when you said you would. And you're 5,000 years older. We better scratch that down in cuneiform, I think it's, who's the guy studying the advance of tech? I think it's Michael Tellingham or something. I think that's his name. Okay, so I'm going to call it a night. Thank you very, very much for your time. This was a bit of a blockbuster in terms of laying out a lot of things I've wanted to talk about for some time. But really, I don't want to talk about things until I have evidence that is basically self-evident. And I'm just really pointing you to it and saying, well, this is what I think, but I think that is what it is. And so I think we're at that point that I could share these things. I wish I'd had access to a decent SEM over since I was last on Alan's in 2019. But, you know, these things are the way they are. And in the intervening time, I was able to work with Henk and David with the Vega experiments and develop the Ultra experiments. And so I think everything worked out rather nicely. And through this process, I've never worried, really, if something appears to be a success or not. But what I've tried to do is get the best quality data at every step of the process. And I'm glad I did that, because referring back to things as I've done tonight, you get to see things, for instance, in that 2017 hydrodynamic system from Suhas Ralkar in India. You get to understand precisely how nature is organizing this matter. And it's been an honor and a pleasure to do this work. And I think we're probably getting towards the end of understanding what O is and what it can do. And I think moving forward, we need to start moving towards applications. And I think you guys are all in such a huge advantage. And there we go. So thank you very much for your time, and I will see you in the next video. Buenas noches, dobro noc, buenas era, good night.